And we are excited that you could join us for the rest of the program. Jackie will get us started with this session on regional versus global, right? Yeah, regional versus global issues.
We're friends today, right? Can I get someone to, can you get the computer? Thank you. Can you hear me okay? Yeah. Okay.
Yes, we can hear you. Thank you.
All right, good morning. We're going to start day 2. This session will be on global versus regional perspectives for modeling climate change and migration impacts. We have Alex, who is here, and then we have, is Paulo online? Yes? Yeah.
Yes.
And Mita DeWitt. I'm going to allow them to introduce themselves and discuss a little bit about the key gaps in modeling for research and opportunities when it comes to climate change impacts. Oops, I'm sorry, I'm on the wrong one here. And we will hear a little bit different perspective from Mita DeWitt. And I'm very grateful that everyone is allowed this opportunity. So I will pass it on to our first speaker, who is Paulo. So Paulo, the floor is yours.
Thank you. So I can share my screen. Can you hear me?
Yes.
I cannot share the screen. I need to be enabled. If someone can make me co-host.
I said to try again. Oh, yeah, if you try.
I'll try. Yeah, now it works. Thank you very much. Yeah. So you should be seeing my slides now. And well, thank you very much for the invitation. And I'm a professor of environmental sciences at the University of California, Berkeley. And I will start with saying that I got interested in this topic from different perspectives. A few years ago, we were able to reconstruct the global network of migrations. So I'm trying to remove this banner because it's it doesn't matter. Of migration, so we used the global census data, and for each country we had some information on a number of people living in the country who were not born in the country, and reporting also the country of origin. So we were able to reconstruct this global network, and here it shows only the main links of migration. And what we found is that over time there has been a globalization also in the process of migration, in the sense that there has been an increase in the number of total number of migrants, and also that this network has become increasingly connected, which is usually a measure used for processes of globalization. Interestingly, according to these official records, of course, there is a lot of issue of underreporting, and this data set doesn't capture the magnitude of and the extent of this phenomenon. 2 to 3% of the global population are international migrants. And of course, then it's interesting to go from this global perspective to something more regional. So there are, if we look statistically at the community structure of the network shows the property of modularity, in the sense there are community of countries within which people move much more than between community. So there is a community structure that reflects overall language and identities of language and religion. They challenge now to look at the extent to which these migrations are induced by environmental conditions is very, this analysis is very complex. And I will divide it into steps. First, what sets people on the move, when, where, how. And so trying to relate this driver to environmental conditions. And then where do these people go? So let's start from the first one. First of all, the complexity of the process of environmental migrations is also reflected by the diversity of definitions of climate, migrants, refugees, or if it's mobility, displacement, migration. And we did an analysis of these are various definitions that have been done. And so you can see that there is, again, depends on the driver, and depends also on whether it's a forced or not forced migration. The terms refugees often used for forced migration. According to the convention and protocol on the status of refugees, that would be an international migration, but the term is used also for locally, internally displaced people. This analysis also, the nexus between migration and environmental conditions is really complex to the point that we have a rich body of literature or studies on this topic, but we feel that often there is we still need to pin down this connection, this type of nexus. This is complicated by the fact that there are often multi-causality factors. So it's not only that migrations are driven only by environmental conditions. There are time lapses in causation, and also the drivers of environmental migration vary from country or to country or region to region. So we did a meta-analysis to try to capitalize on this rich body of literature, trying to pull out some underlying factors or some educate ourselves on the way we could approach this problem. And we considered like more than 600 studies. Then through different screening and filtering, we came down to 87. For which we try to pull out information on the underlying drivers, what is the timing, the number of people involved, the geographic patterns. And of course, these studies are not only from the environmental sciences, but they are also a lot from the social sciences. And so there are also different ways of looking at and characterizing environmental drivers. This is an example. This is going to be a long table that shows the type of information we were able to collect and in this analysis. And we then tried to get, probably it's more useful to look at, this was the analysis done for Africa. And we see that where most of the migrations in the last 50, 60 years, the period covered by this analysis, took place, and which were the preferential countries of departure or of destination. And a picture that emerges from this is that in the literature we tend to identify drivers by looking at push and pull factors. So what is the factor in one country that makes people leave, and the pull factors is what attracts and what are the countries where these people go. And of course, it's a list of factors, and here in red I highlighted only the environmentally related ones. Then if we look at these environmental drivers, we could classify them in direct drivers. So like a climate event that has destroyed crops, homes, or other sources of livelihoods. And on the other hand, there could be indirect or underlying drivers, which are the policies affecting the economic development that makes some regions more vulnerable to environmental shocks, the presence of infrastructure, the presence of other forms of political, technological vulnerability, and so on. And if we organize them, we found overall that in this body of literature there are two major drivers. One is associated with a lot of water, and then depending, again, some of these studies are not done by environmental scientists, so were classified as heavy rainfall, storm, cyclone, riverbank bursting. So this leads to a certain number of internal displacement, and it gives us an idea of the magnitude of the phenomenon. 6 million people caused, around 6 million people caused by the excess of rainfall. And then we have also the opposite case, the drought, water scarcity, and that lead to crop failure and poverty and famine. And these are again in the order of magnitude of 6 million people. So this is to say that, of course, when we go and analyze, we will need to develop a very comprehensive. It's not that one driver is a lot of water or water scarcity. One is prevalent over the other one. So we need to have a comprehensive analysis of many forms of environmental forcing that can contribute to this. So now we go to the analysis of migration displacement, and where will these people go? And so there have been historically very popular models were the gravity models, but in recent years there has been a very successful model, in my view, that is this radiation model by Simini, because it's a relatively parameter-free approach. It's based on it's called radiation, but it has nothing to do with solar radiation or with climate change. Radiation is because of the physics of radiation. They use an approach based on statistical mechanics to determine with what likelihood one individual from one country would decide to move. And this is related to the distribution of population in that region. And then once what is the likelihood that this person will move to one of the adjacent regions as a function of distance and also the distribution of population in those regions. So this model was developed initially to study commuting, and clearly in the problem of commuting, there isn't the asymmetry that we expect to find in the case of environmental migrations, in the sense that in this case we need to have a region that is more likely to generate migrants because of its susceptibility to a certain environmental forcing. And then so we need to we had to modify this model. This was the study done by Davis in 2018, and so to account for the fact that there is one place that generates more, emits more migrants, to use the term so used in this in that paper. We applied this to the case of Bangladesh and the case of sea level rise. So to identify within this is all internally displaced people, so we don't need to deal with the issues of international barriers offered by border lines, and we studied areas that are more susceptible to flooding using different scenarios. And then we identify some regions that are more likely to produce or to have set people on the move. And so when we apply this model, we are able to identify the regions where they migrate from, where migrants live, and regions that are going to receive migrants, destination points. And so if we do the difference between number of arriving and departing migrants, we can determine a certain pattern of migration induced by sea level rise. So it's clearly the southern part of the country. And this model performs relatively well. This is an analysis we confirmed with our baseline model with some databases, and we found that comparing different databases on lifetime migrants or 5-year migrants from this region. So there was a good agreement. So I think I am running out of time, and I apologize. So the conclusion is that the nexus between migration and drivers, of course, environmental drivers, is complex. And this modeling requires to account for different pathways through which migrants are induced to move. And so this requires an analysis of the environmental drivers, how these affect livelihoods, and also exposure to environmental risk, and exposure also to crop failure. And so then the analysis for once the source points for migrations are identified, where migrants go, at least we had a positive experience with this radiation model, which has the advantage of requiring a very limited number of parameters. And with this, I realized I took longer than I was supposed to, and I'm done. Thank you.
Thank you, Paolo. So do we have any questions? We're going to take the questions and then do a round of Q&A at the end, but do we have any questions in the room? Yes, Diego.
Thank you for your presentation. My question is, you said migrants are, I don't understand how migrants are aware of the less exposure to environmental stressors on the receiving communities. So if you can elaborate on that, on the mechanisms in which they're informed of this or aware of this, or is just a correlation that was done afterwards, assessing the exposure to climatic stressors? Thank you.
Well, that's usually considered as was not accounted for the. I see what you're saying. Yeah. There is in this literature, there is often this notion of the pull factor. So what attracts one person to go to a certain country, and can be better prospects for finding a job, to opportunities for some cases can be education, can be many things in the broader context of migrations. In the case of environmental migrants, if a migrant moves to another place, the environmental conditions, better environmental conditions could be considered as a pull factor. I don't know if your question has to do with the flow of information that informs migrants where to go. In some cases, is not even necessary. It depends on how this whole process happens. Sometimes if it goes through the agencies themselves direct people in a certain direction, if it's a major environmental displacement.
All right, thank you. We're going to hold the question till after the other two presenters. But thank you very much, Paolo. We're going to move on to Alex, and then we'll take more questions and do the Q&A at the very end. Thank you.
Thanks, Jackie. So I'm Alex Desherbinen. I'm a geographer and working at the Climate School, Columbia University, with a group of people working on climate mobility. So I'm sharing some thoughts that have benefited from being part of a larger community of people working in these areas. I did find that Diana Liverman's talk yesterday kind of helped frame a number of issues, and I'll touch on some of those today. I'm also maybe someone who's been around a little bit longer in this field. So I started working in around 2007 or 2008 on some of these topics and have continued since. So I was asked by Beth Fussell to talk. I'm going to divide my talk into two portions. One is to look at habitability, and I am going to try to refer a little bit to yesterday's discussion so that we can kind of start integrating a bit what people's various thoughts are and what's been said. So Cascade almost stole my thunder yesterday. I can't move the slides forward, so someone can help me. Click back on the slides so that I can. Okay, thank you. I'm still seeing it doesn't really matter, but there's the controls are still at the top. Thanks. The concept of habitability is something we took up in this article with my colleague Radley Horton at Columbia and David Rathel at Oregon State, Michael Oppenheimer. This was published in 2021, I believe, and around the time of the Managed Retreat Conference, which Beth mentioned yesterday. And we basically defined habitability as the conditions in a particular setting that support healthy life, productive livelihoods, and sustainable intergenerational development. And I want to just add at a reasonable cost, because I think if we don't take cost considerations into account, then we kind of consider the South Pole Amundsen station or potential habitation of Mars as being also, you know, something that could qualify as habitability. But we know that from historical evidence and from current evidence that people have lived in very disparate and often very harsh environments and thrived in those environments. So, and they don't necessarily have to do so at great cost. We posited that climate change undermines one or more of the following dimensions of habitability: basic survivability, livelihood security, and society's capacity to manage environmental risk. This has to do with essentially climate change undermining the very foundations of adaptation and resilience. If your governance structures are being affected by climate impacts, if your GDP declines by 50% because of a storm, all of these things are going to undermine the capacity of society to respond. So we started from the premise that there's a lot of work out there. Many of you are familiar with it, of these top-down, process-based, models that are driven by global climate models that essentially help to identify hotspots and warn of potential dire consequences. However, as we've been discussing, these are often overly deterministic. So how do you solve that problem? And I refer here to Mike Hume and his article, Reducing the Future to Climate. The future is not going to be climate. There's going to be tons of other things going on, and we know already life is very complicated, and we often focus in on the climate because that's of personal interest to us, but there's going to be a lot of other things that determine what kind of future we have. We do posit that amounts of distress migration are likely to rise in response to climate stressors, and that there also be involuntary mobility. And bringing in the policy perspective, the Global Compact for Migration does call on governments to strengthen joint analysis and sharing of information to better map, understand, and predict and address climate or migration movements. And so climate change is going to impact all of these, and these kinds of assessments that we're doing and the kinds of research that we're conducting are important to policy. What we propose in the article is a marriage of sort of top-down assessment and more bottom-up co-production of knowledge with local communities and stakeholders, as they're often called, and as well bottom-up modeling approaches such as agent-based modeling, which are kind of more suited to local circumstances. Here's just a smattering of different kind of hotspot mapping efforts that have been out there. The top one is from our article and basically refers to sea level rise, return periods in the dots along the coast. And what you see is that what used to be 1 in 100-year events, or currently 1 in 100-year events, will either occur every year or up to 12 times a year in the future in some locations. And that the wet bulb global temperature return periods are going to also get much more frequent. This is for 33 degrees wet bulb globe. So those are, kind of two signifiers that these are potential areas that may be at risk of different kinds of climate impacts. An early example of doing this sort of thing was Georgie did a kind of hotspots analysis for using a bunch of IPCC, I believe it was probably stress model outputs or whatever that first early model outputs were, and basically takes temperature, precipitation, a number of other variables, excessive hot days, precipitation, et cetera, and looks at which regions will be most impacted. On the right-hand side is a kind of, it's still back over a decade or so ago, but it's essentially an ecological kind of perspective where humans tend to preferentially inhabit certain types of climatological niches. And it looks at the shifts that may occur in the future due to climate change that would essentially change the optimal conditions for human habitability, and they overlay on that demographic pressure. So this one actually includes both the future climate impacts, but also changes to demography or population and looks at those conjoint risks. And then in the bottom is one that many of you may be familiar with, looking much more just at the temperature dimension and sort of proposing that many people will have to move because of these climate impacts. Obviously, these can be modified slightly by taking into account social vulnerability. Diana correctly stated yesterday that social vulnerability pre-exists and isn't determined by climate impacts, but rather is contextual in nature. And if you take a political economy perspective, there are a lot of vulnerability generating mechanisms and systemic factors that are already causing people to be at risk of climate change even before climate factors even come into play. We built on the article we wrote and also some work that the Habitable Project is doing in Europe with a PERN cyber seminar. And if you want to get more information, you can go to the link at the bottom of the screen that focused on habitability in the field of population environment studies. These are some of my summary bullets from some of the different presentations. There's this kind of physical dimension to habitability, which we often focus on, but we really need to look at the socially constructed dimension of habitability that relates to capabilities, what people can do with the environmental resources they have, what power do they have over their local environment. And then there's also an emotive or sort of human dimension, which is there's place attachment and ways in which people consider places home and they don't want to leave those places. There's also this emergent dimension, which is kind of like vulnerability and resilience, which you can't really put your finger on habitability until something pretty bad happens or progressive changes occur in ways that cause us to essentially assess that habitability has declined in that area. Habitability can be ascertained as an accumulation of individually based decisions. People vote with their feet. So basically, if you see populations declining in an area, it may signal that habitability has declined. And then, this is elaborating a little bit on David Rathell's point that, there's governance aspects, food security aspects, and this also physical and psychological safety. I think something that, a lot of the people on the right forget is people are not fleeing countries in low-income parts of the world, places like Venezuela, because they want to get to the United States necessarily. They're seeking safety for their family and they're seeking a future for their families. And we have to remember that human element, that these are people making rational decisions in the face of really uncertain circumstances. And then, then this idea of social tipping points at the bottom, I think is a really interesting concept. I don't think it's been well operationalized so far, but the idea is that, if a certain number of young people leave a village or the best and brightest or whatnot, you begin to see more people maybe leaving and the actual economy of the place falter. And you can kind of think of these little Dust Bowl towns in Texas or things like that. The Last Picture Show comes to mind from the 1970s, where there's literally not much going on in that town and that sort of social tipping point occurs. Reflections on yesterday's presentations. I think there's a little risk that we all have. And in fact, the diagram that was showed twice yesterday from Cascada in my paper does take climate on the left-hand side and is sort of the starting point, but it really is at the starting point. And here I refer to some of the work of Jesse Rabeau, who's actually just up the road here at American University, colleague I've been talking with and in dialogue a lot with, and the whole notion of causality and things is that he's really wrestling with. This is the kind of paper, The Framing the Frame, that he wrote with my colleague Fabien Coutier. But there's also a paper he wrote on climate of anxiety on the Peanut Basin of Senegal. And he went to villages where many people had lost relatives in boat capsizing in the Mediterranean. These are young men who are seeking their way. If you've seen Io Capitano recently, this is a great portrayal of some of the risks that these young men take. But they're leaving often because the prospects of making a profit as a smallholder agriculturalist is just minimal because local state monopsonies basically buy all the peanuts at regulated prices, and the farmers get increasingly indebted, and it's a form of peonage almost. So we have to look at these underlying social factors. He describes it as a precarity where the farmers are sitting on the edge of a cliff. And yeah, does climate come along and flick them off the edge of the cliff? Perhaps, but there's also a lot of other factors that are behind that. Also, let's look at the way that we as academics in the West categorize people as migrants or displaced or whatever. This is that we're at risk of othering people and missing their voices. I'm influenced by Khosravi, wrote a paper just recently on doing migration studies with an accent. I'd recommend that. It's really looking at these underlying, classification systems and theories that we use, which are really defined by Western academics. What do they say themselves as migrants? What are their lived experiences? I also want to recommend Petra Schachert and some others who've done really good grounded work on the kind of lived experience of migrants and the factors that are influencing their decisions to move. But a little simplistic thing that we did was just summarize 3 different surveys in West Africa of what migrants believe. And they're basically saying they want to make more money. They're leaving because of violence and other issues. They're also leaving because of family and personal reasons, marriage, education, those kinds of things. And environmental stuff comes really at the very end, 3% of the total. That doesn't mean that environment doesn't influence some of these other factors. I wouldn't want to say that, but it's just to say that the actual perceptions of migrants often vary from what we would consider to be important drivers. So let's go to the mobility modeling aspect. I'm going to have to be really brief here and telegraph some ideas, but basically, why do we do this? One is because academics love their models, they love their tools, and we get funded to do it. And so it's a salient topic that's rising on the policy agenda, and there is money to do this kind of work, and it's exciting to many of us. And so let's just be honest about that up front. Demographers have always been involved in projecting population. In fact, I started in this area working on a paper for the population division of the UN. We said, Suzanne Adamo and myself, we said, look, you're going to have to start thinking about whether the cohort component method of projecting population in the future is going to be sufficient to kind of project populations into the future under situations of higher and higher uncertainty and risk. And they were kind of laughing and said, Tom Buettner said, leave that to us. We're the experts. We know that stuff. So I said, okay, fine. But I think we do need to take these things into account. Humanitarians want to know where displacement is likely to occur in the future, early warning systems and the like. Development actors want to know what are the potential limits to adaptation. Are you going to be starting to pour good money after bad in certain locations? I don't want to talk about it could appear as kind of a redlining, and that's something we could discuss, is at what point do our models kind of create a kind of a new form of climate redlining. Receiving countries want to understand what the magnitudes of future flows are. We were talking about it over dinner last night. We all, I think, sympathize with the plight of the migrants, but we also live in a world of realpolitik and nation states. And governments actually do want to control their borders to some degree. I don't think that's an unreasonable need either. And I think it's something that we have to balance in this area as well. And then what if scenarios cannot really be done in the real world. We have to actually use models in part based on policies to sort of tease out what might happen if you close the borders, what might happen if you start granting more humanitarian visas or that sort of thing. So there's different scales of modeling, temporal and spatial, the sort of local and very immediate scales of hours to days is in the kind of realm of displacement or evacuation modeling. And then there's the more longer term migration modeling, which I think we're kind of focusing on more in this workshop. I believe that modeling should be grounded in migration theory. I worked on this paper with some colleagues, and we basically, on the left-hand side, you see the sort of the more traditional econometric studies and the kinds of theories that are invoked by those studies. And on the right-hand side, you see a table with the projections and future scenario studies. These are not a large number of studies. We weren't completely exhaustive in the literature, but we wanted to get a reasonably robust sample of about 75 studies total that we analyzed for the different theories that were invoked. And basically what you see is, neoclassical still dominates at the top. And this is the basic Homo economicus argument that people move for rational reasons based on whether they can earn a higher wage somewhere else or wage differentials. New economics and labor migration is often invoked. This is kind of the household risk reduction strategy where you send someone off and they send remittances home. And basically that creates a better situation at home. And then there are a bunch of other theories, but there's roughly 10% of studies in both cases that cited no theory whatsoever. There's basically no theory. So you're kind of like, what's going on here, guys? Let's wake up. There is theory out there. Let's start applying it. Lori's written a lot about this. We built a lot on her work, so let's be honest. So we kind of think aspirations and capabilities might be a really good way to go, where you look at whether people are able to move on the one axis. And that's on the kind of top. And then the other is whether they actually want to move. And then you say, if they can move, and they're capable, but they don't have the volition, then they'll stay in place likely. But there are people who want to move, but don't have the ability, and they're more like involuntarily immobile and trapped. There are a bunch of modeling approaches that have been applied. I'm going to just go through quickly. This is the basic exposure model. Sea level rise is going to be by X number of meters. People there are going to have to move out. Let's just face it. They're not going to survive. We know that's simplistic, but there's, a lot of that kind of thing that's been done, whether it's sea level rise or drought or some other threshold that's considered non-habitable. Agent-based models are much more bottom-up but require a lot of data. They're really wonderful in exploring the internal dynamics and sort of scenario building and policy applications. System dynamics haven't been used as much, but they are used for displacement modeling and could be used in some of the new forms of computational modeling. Statistical extrapolation is basically just taking current statistical relationships and saying, if all things are equal, temperature increases by such and such a percent, crop yields decline by such amount, and we're going to see this amount of migration from, say, Mexico to the United States. This is the machine learning approaches that have been applied increasingly. I don't include radiation here. It's sort of embedded in here, I think, in some of the machine learning kind of approaches. Gravity models essentially use the historical kind of propensity of people to move from less dense areas to higher, more urbanized environments, the agglomeration effect we would call. And that's just a proxy for all the things that urban areas essentially represent, like jobs, education, et cetera. Integrated assessment models are really complicated and are only, I would say, rarely used, but this is an example from Helen Benveniste and Michael Oppenheimer looking at IAM and applying it to the question of migration between countries. And we're working now with a colleague, Mikhail Brzezinski, on a computable general equilibrium model, which basically looks at the economic, it's an economically based model, let's be honest, but it looks at damage functions and things like that and figures out both whether people could get a higher wage in another location and also what the barriers would be for them to do so. Here's a couple of good papers I commend to you. I'm not going to be able to cover them, but basically there's a special issue at the bottom on climate migration modeling, and you can go to that and refer to this in Frontiers in Climate. But basically, Robert Baer and others look at this question of how so many quantitative studies that we have to date contradict one another. They basically say one area gets drier, people move out more. Another area gets drier, people stay in place because they can't move. And these things obviously are nonlinear, and there's a bit of that inverted U-shaped curve that Diego was referring to yesterday. But there's also a lot of other things going on, and what are causing these multiple effects. So if we can't predict the past or explain the past, how are we going to be able to predict the future and actually model out? And then they also just say this is an exceptionally complex challenge for quantitative modeling and forecasting. And I think we just have to take that to heart and realize we're dealing with really complicated socio-ecological systems. Further model refinements also require inputs from the broad community of experts. This is from Carolyn Schul. Greater transdisciplinary collaboration. I'll just share as a final slide about this one example. This is one that we worked on with colleagues at Lamont and Columbia more broadly, involving climate scientists, geographers, and economists, a system modeler, an environmental engineer, and a political scientist, as well as a bunch of hangers-on. We invited a bunch of other people to our first party, which was just before COVID. We had a great workshop, and then a bunch of those people actually were kind enough to continue on the journey with us and sort of explore these issues. But basically, yeah, all the things that Pierre said yesterday, shared vocabulary training, limited resources, all these things are impediments and require work. It's really hard. There's this kind of ladder that they described in the GCR, one of our inaugural workshops before we got started, of like getting to the point where you're the iron chefs of fusion and you're all thinking along the same lines and you all have a shared such a conceptual framework, almost like you're creating a new discipline. And that sort of varies a little bit from Diana Liverman's conceptualization yesterday of co-production of knowledge with local stakeholders. So there are these two different models of transdisciplinarity out there, and I haven't heard of one that's being kind of universally accepted. But I do think it's really hard to get from the bottom to the top, and maybe even the top is aspirational and can't quite be reached. One of the things I will remark is the fact that social scientists are in some ways driving the ship here is totally new. 25 years ago, when I first went to these kinds of workshops, the social scientists were an afterthought, and they basically are invited to nod their heads and say, yes, I'll sign on to your proposal for your $1 million or $2 million NSF that, you know, and I'll add a little social component at the end. And I think that's great. Last word is that we're going to have a workshop in September during Climate Week. And it's in New York City. So if you want to go to Climate Week anyway, but also do geek out a bit on climate model into comparison, join us, send me an email, and I'll be happy to plug you in and at least give you more information. Thanks so much.
Thank you so much, Alex. I really like the direction this is all going. I don't know if anyone else sees those threads being pulled, but any questions from in the room? We're going to hold the answers though until the very end, but any questions from in the room? All right, so we'll move on to our third presenter, Mita DeWitt. Thank you, Mita.
Yes, good morning. Yake Tutat. I'm going to set my timer here so that way I'm not going over. Dleka klenach, Mita DeWitt, Yuchat Duasak, Linget klenach, Zetzinak, Yuchat Duasak, Nanyai Nachatsati, Kachari, Yadi Chatsati, Shtakin, Kwan Ayachat. My Tlingit names are Zetzinak and Kat Duklaat, and my adopted Inupiaq name is Tigigaluk. And currently I am on Shinget on E in Aquan or Juneau, Alaska, actually attending a Just Transition conference. So we have converging realities on the same topics. I'm here today to share traditional ecological knowledge. Some people call story, but we have oration or orators as part of our culture who have kept the traditional knowledge, and it is something that has been intentionally transmitted through tens of thousands of years, and our time is based on geological time. And so I'm going to share some experiences with you because as Indigenous people, we have been through this before. So in Alaska, when we had the great ice sheets, they were actually heavy enough to depress the land, and there was other land that was above water at one point of time. And we had the great glaciers that started to move and close off sections of land. And at that time, we had people who lived inland, which with our geopolitical borders, they didn't exist that time, but now we would call it Canada or Yukon territories. And at one point in time, the Tlingit people were Dene-based people, and we lived inland. And we had an experience of climate change where the climate was changing rapidly. At that time, we had loss of our traditional foods. So, you know, the things that we would hunt for or fish or gather. The Tlingit people were also known to grow food, but our conditions were changing. And because of the shift in the climate, there was the experience of starvation, the experience of sickness, increased mortality rates due to injuries from destabilized climate or expected, terrain. And so the people, they came together because they realized at a certain point that if they didn't move, that they would no longer exist as a community. And this is a story that humanity shares. We have many different migration patterns and stories throughout humanity's history. But they knew that it was time, and they had a river that they had to travel down, and this river went under a glacier. They didn't know how low the ceiling of the glacier would go. And so there were some elder women they decided that they would get in the canoe and travel under the glacier to see where it went and to see if it was safe, because they're in their end of years of time and they couldn't contribute much to the community, but they knew that that was something that they could give to their children and grandchildren and all of the generations to come. And so the community decided to clean up and put that town to sleep, the village to sleep, which means deconstruct the houses, and, you know, burn anything that was unnecessary, making sure that it was left as clean as possible. And the two old women got into the canoe and they put branches in their hair, so that way if the ceiling under the cave, the glacial cave, started to come down, they could feel the depth of the cave. And the community sent two young men up and over the glacier to watch. And they were sent in twos on purpose because it was treacherous and it was not easy to pass. So they're the strongest young men that they had. And as the women were going, there's this cry song. I can't sing you the whole song because there's rules about how we share story or songs that we can share. But I can share some of the vocables with you. And it's called a cry song, so a grieving song. So as the women were going to go under the glacier, the community sang, "Way, way, ya, hey, 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 ya, hey, hey, yay, hey." And they start to cry and weep. You know, they're grieving because not only were the women about to possibly perish, but their community was all dependent on their success. And so the women went under the glacier on the river in the canoe, and as they were traveling, they did feel the ceiling come very low, but they were able to make it, and they made it out to the coast. And the young men who were watching from the highest point were watching for the signal that they made it, and they saw it, and so they went back to the community, and the community packed up everything, you know, all of their belongings, anything that they couldn't burn or recycle or, you know, put to rest is what we would call it in the community, and they took it with them, and they went under the glacier and made it to the coast. At that time, there was already people living on the coast, and my great-grandmother, Tilly Paul Tamery, she always says that we came from the coast as well. And there were the people who populated the Pacific Rim. She would say that those people who put those statues on those islands, they were already there. And so when the Dene people came out to the coast, they were received by the coastal people. And, you know, at that time they were sick, they were malnourished, their spirits were grieving, their souls were grieving. And on the coast, there is abundance. There's tidal foods and fish and deer and berries and greens and all sorts of abundance. But there is still a soul level grief that the people carried with them. And so after a time, once they were nourished and rested, the song that helps repair that grief for the people was sung. And it's originally it was Elisa, but now people say Henisa. And the meaning is come out and be in joy, be alive again. And that song to lift the spirit, ya ha hey ya ha Henisa ya awa aya awa that's the vocables for that song. And they're so old, they're just called Canoe Song 1 and Canoe Song 2 by the Deshitan people. It's as their caretakers for those songs. And what we've learned from this is quite a few things, actually. Indigenous people from all over the state have stories, traditional ecological knowledge or traditional Indigenous science on climate change. Depending on where you go in the state, they have knowledge that Alaska was warm once, it will be warm again. They have knowledge to share that sea level has had many experiences of rising and falling, and we have different communities that are always, just above the coastal line. So there's communities that are up the mountains 60, 70 feet, or communities that are old communities that are underwater. So this migration and climate change is not a new experience. Some of the experiences that are new, again, are the geopolitical boundaries that we place, or the law and policies that we place on humans and the ability to migrate. The challenge with what we're experiencing now is, of course, the human contribution to climate change and the acceleration at that we are experiencing. And these stories or implications, Wilson Justin, who's a Ahtna Athabascan elder, he talks about climate change as starting with contact, because that's when our relationship with the environment went out of balance. That's when the overharvesting of animals started in this area. So that's our concept of an imbalanced relationship. And the values of Indigenous people, sometimes they're hard to wrestle with because there's so much truth to them. We have to look at ourselves as humans and our consumption. What are we filling with our need of consumption? What kind of emotional or spiritual wounds are we feeding that are unsatiable with our consumption? Those are things that we have to address to transition through climate change and successfully survive as our culture as a global people, and also as our nation, the most powerful nation in the world. As we move forward, these stories or traditional ecological knowledge help give us guidelines, and we have growth through rites of passage. And right now, humanity is in a rites of passage, and we are challenged to grow, to evolve, to take responsibility for ourselves and our behavior, and to work together so that way we can thrive as we move through this. I'm told and understand that we won't reverse climate change. That's something that's already known to Indigenous people. But what we can do is mitigate the effects that we have. And because we cannot do an external large migration, we're not going to Mars, we have to do an internal journey and look at ourselves in a deep and truthful way. And how do we transition so that we do not continue to cause harm and we do not continue to repeat these patterns in the future? So Ganesh Chish, Ganesh Chish, Ganesh Chish, Asha Kakao. Thank you for allowing me to speak today.
Yalakpak Meda. Do we have any questions in the room? Yes.
Thank you. That was amazing. I'm curious, you both have told such powerful stories, and I just really appreciate them. What's it like in those villages right now? I mean, how are people feeling in terms of the pressure to relocate, given the amazing history that you've outlined? I wonder what it's like on the ground. I'm really just curious, because it's got to be tough, and yet there's this narrative of we've done this before. How does that work? So that's my question.
Okay, Mita, do you want to answer that?
Yeah, I was wondering, because Jackie can answer that as well. Right now, what we are experiencing on many of our coastal communities, because Alaska we generally live on the coast, and it's about 80% of our communities have to move. That's approximately 186 communities, and they're mostly indigenous to Alaska, the populations. And so there is immense grief and frustration that is happening, because a lot of our communities that are settled in these areas used to be summer communities. And so our people were very intentional about where they settled. So there was winter communities that were up higher, safe and sheltered from storms. And then there was summer communities that were generally for fishing or access to open water for transportation, trade, fishing, and they got settled for as, you know, transportation hubs for Western processes. And right now there's so many laws and policies, and there's so the state of Alaska, you know, is 20% of the United States, but we're 60% federally owned. And then there's corporations that own, and municipalities and state and private. And there's so many boundaries that it doesn't give a lot of movement for communities. And then it's also inhibitive because there isn't enough money to then give appropriate land you know, research and whether or not it's a good place to settle. You know, is there bedrock? Is it permafrost? Is it, you know, going to slough off? Because there isn't funding to move a community unless you find the right kind of terra firma, when traditionally people would already be allowed to just transition and know where they need to go. And so we're basically landlocking people and imprisoning them in these spaces that are falling off into the ocean or you know, crumbling under their feet. Jackie?
Yeah, thank you. You know, both Mita and I work with communities, and most of the communities I work with are under 300 in population. But, you know, there is a sense of hope because of that interconnectivity to our past. And the elders remind us that, you know, the things that are happening today are not caused by us, they're caused by others. And so to recognize that and to acknowledge it it does make it a complicated scenario. And it's very generational because, like I mentioned yesterday, we have our traumas are very surface. You know, we have living, my aunts and uncles were the boarding school era. So the trauma is at the surface amongst us in our social structures. But what we are finding is with this ecological knowledge system and this traditional way of thinking, that information is processed different. And I think that this is something that I don't think anyone has really studied. Like, Indigenous people have this intricate relationship with nature, so they process information differently than if it's a learned setting. And so a lot of it is simply in our DNA. Both Mita and I work with traditional healers across the state. And as that vibration of those healers rise up, it's more about this essence of relationship and that relationship with nature. So I think that there is something that all of humanity could learn from that. And yeah, it is a dire strait, but we are also reminded by those same elders that this wasn't our permanent home. We were able to move. Unfortunately, some of those communities don't have the privilege of time, and so it makes it very difficult. But I would say that you know, what we aren't seeing is we were told when I started in this work probably a decade ago that there would be this mass migration. Everybody would move to the cities, and we would have these small pockets of culture in these cities. We only have one big city in Alaska, so and some have, but such a small number, and most of them out-migrated because of overcrowding of housing. And so there was a housing issue. So it wasn't necessarily because of any other social, you know, some go out for education and come back, some go out and don't come back. But again, I think we have to understand at that local level not only the disparities, but the inspirations and the hopes from that traditional knowledge. So it is emotional work. I'm not going to say it's not, because you have both when you're in community. You could sit with an elder and be inspired and learn so much in a few hours. And then you could sit with a high school kid who's just struggling, how do I fit into this weird world I live in? And so, but I don't know that that's necessarily just in Alaska, in our rural communities. I think that's probably anywhere in America. Okay, so do we have any other questions in the room for Mita? Okay, I have one question online for Paulo. Did the bibliographic search include only English literature?
Yeah, it did. And the student we were working with, she's from Ethiopia. So initially we were looking at, and the focus of the paper is on Africa and the sub-Saharan Africa. But overall, we referred to the English literature. Yeah.
Okay. Did you have a question? Yes. Oh, I don't see any other questions online. Yeah, I do have a couple questions that I could pose as well. But I think it'd be really wonderful, now that we've heard all three speakers, to just hear maybe some comments on how you feel at this point, having heard all these different perspectives. And I guess I'll start with Paulo.
Well, first of all, I was fascinating by the other speaker's talk. Mida, I found it very interesting, and also I'll I was wondering if I don't know if I want to make a question, but basically was the whole thing of the environmental migration is one aspect that puts always humans in at the center, is a very anthropocentric. And my understanding is that many indigenous worldviews are less anthropocentric, are more humans inserted in nature. So I was wondering if there are any reflections on how this affects also other forms of life that exist in the same land, and if there is also concerns about wildlife not being able to migrate. And that was one of my reactions. The other thing is that is the aspect of land locking and land grabbing that basically limits, is probably the big difference with respect to pre-European settlement, limits the migration of people, and so that's also an interesting, it's a concerning part, because this is something that is relatively new.
Mm-hmm.
So yeah, and so I don't know if there is anything, any thinking, but maybe that on the first part of my comment on the less anthropocentric view of migration and the environmental impacts on the land.
Yeah, thank you. But you're correct. So as humans, we don't see ourselves as superior or outside of the environment. We have nations, as we call them, that's interpretations. We have plant nations, animal nations, fish nations. They have their own social constructs and social protocols. And the way that we view it is that, we don't hunt an animal. The animal chooses to give itself to us, right? It chooses to sacrifice its life for us so that we can have sustenance. And it requires that kind of respect in that situation. And Tlingit people we actually build our whole culture around stewardship. And I think that's especially based on the past understanding of that there can be collapse of an ecosystem, especially in climate change. And so after we came out to the coast and we had the coastal people and the Dene people, they were two original peoples that then, made the Tlingit people with laws that were based on balance and reciprocity. And that's how come we have the raven and eagle moiety. And then from there is a delineation of space, and the concept of land ownership is different. It's not that we own and have dominion over the land. It's that we belong to the land. We're the caretakers of the land. We make sure that there's an augmentation of abundance and a protection of those spaces, as well as, the activities of cultural burning or transplanting or gardening and creating flourishing environments. And so that right now is part of what we have to wrestle with is how do we steward these, fish stock that are dwindling because of the overfishing and trawling or the warming of the streams? And how do we do assisted migration for different species so that we can continue to exist with them in perpetuity?
Thank you.
Thank you both. I'm going to pass it over to Alex for some comments.
Yeah, I guess, my presentation, both for Mita and Jackie, my presentation raised the prospect of doing coupling top down with bottom up. I'd be interested in your perspective on that. Clearly, Alaska represents one of those regions of the world with very high, sea level impacts. It's not just sea level rise, it's the surge, it's the coastal erosion owing to loss of ice. So it is, for lack of a better term, and it's a horrible term, but hotspot in that sense of being an area that is likely to be severely, and has already been severely impacted by climate. I guess what I'm wondering is what your experience has been, or maybe if it's not personal, of people in your communities who have worked with scientists to develop either adaptation plans. Mita, you say you're at a transformative adaptation conference right now, or plans for managed retreat, or other activities that involve that kind of marrying of your own traditional knowledge and scientific knowledge, and what the experiences have been in that domain.
Yeah, there's actually a project that a documentary that was made, I think, in collaboration with Columbia University in my hometown of Kotzebue, and two of my uncles and a couple of my nephews or my cousins. My uncle's kids are not necessarily my cousins, but my nieces and nephews. So, and it was a study on ice, and when you look at the lack of an acknowledgement from Indigenous science, it really is like this. That's the struggle. The struggle is humans. The struggle is this hierarchy of having all these numbers and letters behind your name, and these pieces of paper to validate who you are. Whereas in our culture, the hunters are the hunters. They're the experts of that domain, and they share that knowledge, and they share it very freely. What's happened in the past, unfortunately, is very extractive, and things were taken out of balance. And I think that's a good word to use. If it's done in a harmonious way and there's balance created that's going to benefit all, not just benefit one, I think there are success stories out there. But I think we have to be careful because everything, like I said, the traumas are at the surface. So you have to be careful in how it is approached. And then it really is dependent upon that culture and that community. I'm Inibel, Mita is Tlingit. We have very different, we are both land-based and water-based. We are both coastal people, but we're different cultures and different climates. So the interaction and the relationship, there are similarities, but there are vast differences. And so I think it really is, you can't just clump all tribal people together. You have to understand that each has their own history, and that history is what you're trying to tap into, because that knowledge is going to help current day science and modeling create accurate modeling, not just from when Western contact and Western science began. So I hope that partially answered your question. Yeah, Mita, did you want to respond real quickly? We have a few more minutes and I have one more hand in the room.
I think you covered it great, and I know that we're short on time. So yes, go ahead to the next one.
Okay. Yes, Amir.
Just wanted to build on what Alex mentioned. So we use the term managed retreat, meaning the government will come in with some plan and investment and move people away from the coast in this case. How comfortable are local communities with this idea? If government comes into your community today and say, oh, I have a great idea, I want to move you away from the coast, how do you think local communities and tribes will respond to that kind of plan? Any thoughts, any ideas?
Well, I currently work with one community that is in full relocation. I'm just gonna give you some reality here. Our communities were forced to locate there. So you have to understand the context and the history in which we're dealing with. A managed retreat, we have many definitions for that, and I think that is part of the jargon confusion. In Alaska, most of our rural communities have social housing, so they're owned by the government. No one puts it into that context, but we have this system in which the government funds the building of homes in our communities. Some of the homes eventually are the title is handed over, but there's this complexity of layers of governance in community. We have the Alaska Native Claims Settlement Act, which allowed the people as a whole in particular regions that were then defined by the government to own land base. So they own the land and then they own the surface. And then in these same regions, there are over 200 village corporations that own the subsurface. So you have this surface and subsurface, and then you have the tribal governance, which is they govern the people. And so you have different landowners, and depending on when it was implemented, it might have been a township act, which superseded ANCSA. So you could have all these layers, and then you have a tribal government, you have a municipal government. So you're dealing with these entities, 4 entities with a population of 200. The people all are related. So depending on what hat you're wearing and what side of the table you're sitting on, that in itself causes conflict. So in the case of the current relocating community, it took 7 years of negotiating with the U.S. government to exchange the land because the land was owned by the government. It was a refuge. And so finally they get the land exchange, and meanwhile Mother Nature is chomping away at their village, and temperatures are rising, permafrost is melting, so they're in dire strait. This community currently is about 50% relocated. They've been in this relocation for almost a decade because the funding is in pockets of funding depending on which agency funds which component. So you have transportation funding that builds the runway, the airports, and the roads. You also have BIA tribal funding that also builds roads and maybe some housing. You have the NAHASDA Act that funds through HUD funds some housing. And so it's very complicated. And usually in this case, you have one person working on tribal relocation and one tribal administrator trying to maneuver in this web of complexity with all these funders and the government. And the government has to be involved because those are the constraints upon us. There is no individual migration for a family, especially if you have 3 generations in one household. It's very difficult to make informed decisions when you don't have the climate data and you don't have the relationship built with the science and research world to really understand what is the best route out. So again, it's not only landlocked, it's a complexity of inequities that are that were built upon contact and that still exist.
I'm gonna jump in real quick, Jackie, and I don't know, add a layer to that too. So from my experience, most of the communities that are experiencing climate change, if the government showed up with enough money to help them move, they would be pretty happy with that. There's been promises to do that. We haven't seen them in the past. You know, Obama pledged 20 million when he visited, and that's not enough to move even one community. So we have this issue, and from my experience in listening to communities, their challenge isn't necessarily that there's moving. It's one thing is they don't have adequate data or information, but then they're also over-researched as humans and individuals. And a lot of people make a lot of money off of researching these small communities, and then they don't realize any of that money themselves to apply it to solutions. So one of the biggest concerns that I hear about communities is our concept of community is not the same as Western concepts of community. When you think of community, you think of the hospital, the church, the houses, you think of these roads, structures, sewer systems. When we think of community, we think of our people, our relations, our neighbors, you know, these families that have allied systems and sometimes feuds, right, for decades, but they can't imagine not living with that other group of people. And so the fear is the loss of those people, the diaspora, you know, of just being kind of scattered to the wind. And they represent the stories, they're living stories of how they came to that community, how they survived. And so that's some of the biggest challenges. And so if the government showed up with enough money to move a whole community together to somewhere else, you know, inland ways, that'd be great. And then just my really short feedback on this group and listening to the science. I'm really thankful that science is finally catching up. You're talking about sea level rise and the effects of storm surges and all of this water. That's things that I heard when I was 15 years old. So the fact that the realities are starting to converge and agree is actually very hopeful for me. I'm thankful for that. And I'm thankful that I don't have scientists rolling their eyes at me anymore when I start talking about this. So I have hope that we're going to work together and transition in a good way.
Okay, well, thank you so much. Do you have any other comments? Yeah, we have a couple minutes and then we'll wrap this up.
I'll take one of those. Just for my own articulation of what I've heard, and thank you to the panelists again. I think we should start to think, and again, this is my perspective, of the concepts that we're discussing here with Diana again, and we all reflect on Diana's intervention because it was so valuable, in particular describing transdisciplinary research. I think we're falling short if we only consider transdisciplinary in the traditional term of, you know, across disciplines, and not considering what we just heard. So I invite us all to think about those barriers that are keeping us from transitioning to what we are identifying as a way out of our methods. So that's all I want to say. Thanks.
Well, I just want to say thank you all so much and thank everyone online, and thank you, Mita and Paulo and Alex. I think this is very helpful for me as well. And I do believe that as we look at this through a broader lens, I think that's where the magic happens. And again, I just thank you all for your input and for your kind words and for sharing today. We are going to transition into our next panel. And that panel will be, this is session 5. We have a few minutes for a break, and then we will have our moderator, Somaya, come on up and share her panel. Thank you.
Everyone. Hi, welcome to session 5. This is our final session, presentation session before we move on to the synthesis and the final session. This session is on harmonization of spatial and temporal data and models to advance an Earth system science approach to modeling climate and migration. I'm Somaya Daj. I'm an associate professor of spatial data science at the University of California in Santa Barbara. And I'm currently on sabbatical as a fellow of the joint program between ATH and the University of Zurich, Collegium Helveticum. In yesterday's sessions, we talked a lot about data already, but today we're going to continue with the same discussion on opportunities and challenges with data. This panel will explore key gaps and in data and modeling for research and opportunities to advance the study of climate change and human migration. The panel will consider issues from an Earth system science approach and identify key stakeholders and methods to overcoming data gaps. We have 3 speakers, Dr. Chris Pong from UC Santa Barbara, Dr. Ali Mustafavi, who is sitting next to me from Texas A&M, and we have Dr. Deborah Balk from City University of New York. So we first have the presentations. I invite you to hold your questions, and then to the audience online, please feel free to insert your questions in the chat box, and we will have the questions after the presentations. So our first speaker is Dr. Chris Fong. Dr. Fong is the director of the Climate Hazard Center at UC Santa Barbara. And now I invite Dr. Fong to start his presentation, and I ask you to join me in welcoming him online.
Okay, I'm just looking at, oh, here we go, share my screen. Okay, great. Okay, thanks so much, Samaya, for the opportunity to talk about the harmonization of spatial and temporal data and models to advance an Earth system science approach to modeling climate migration, which is obviously a lot to talk about. I work here at the Climate Hazard Center in Santa Barbara with a group of Earth scientists and data analysts who collaborate really closely with an international set of regional scientists in Africa, South Asia, and Central America. And that's a really unique opportunity to co-develop data sets and strategies for monitoring extremes. I'd like to just give a quick shout out to Laura Harrison, Emily Williams, Robert Saldivar, and Pete Peterson, who have done a lot of work on the newer temperature data sets that I'll discuss in this presentation. So we're funded by the U.S. Agency for International Development's Famine Early Warning Systems Network, or FuseNet. And FuseNet monitors global food insecurity, which has really increased a lot over time, beginning at about 35 million extremely food insecure people in 2015. The assessment on this graphic is 129 million for 2023. But I've heard from FuseNet that it's probably going to go up a little bit in their final assessment to 134 million. So there's been, a real explosion in global level food insecurity. And the good news, however, is that, a lot of humanitarian assistance is being effectively moved in many cases to help blunt at least the edges of that hunger. And so here at the center, we've worked for about 25 years developing strategies and data sets to support FuseNet. And much of that work is relevant to looking at problems of migration. And we use what's called a staged early warning system approach. Defense in depth is another kind of related idea that you may have heard about. And essentially, we begin at a global scale with climate forecasts and assessment of what's going on in terms of things like El Niños and La Niñas. We have integrated, interoperable weather forecasts that provide information at regional scales. Personally, I specialize in the development of really high resolution, long weather data sets for rainfall and temperature. Other members of FuseNet, will be using high resolution satellite imagery of vegetation. And then, of course, we also integrate farm and household level information. So, my expertise basically goes from the global to the local in terms of weather, and that's mostly what we're going to talk about today. So if we look at what's been going on in a global perspective, what we've seen is really an unremitting set of El Niño Southern Oscillated related extremes since 2015. And I wanted to show this because I think it's really important that we have an appropriate conception of how climate change is modulating the Earth system. And it's not an exogenous kind of warming trend. It's really more energy moving through the system. And so when we've had El Niño related droughts in Latin America, Ethiopia, and Southern Africa, that puts pressure on households. We've had La Niña related droughts that in places like Afghanistan and East Africa. And so understanding that this climate volatility is increasing, I think is a really important piece of the puzzle. So just picking a kind of one of the most dramatic things that's just happened over the last year. On the left, we're seeing incredibly warm July to February NASA GISS air temperatures over most of South America. If we extract the climate hazards infrared precipitation with stations data in terms of rainfall for that region, we can see that 2023-24 was one of the driest seasons on record, and that we had another similar season during the strong El Niño in 2015-16. And if we go further back on the record, we only find one instance of that in the past 3-4 years. And so, these are all really large scale results, but it's important to understand that there are really dire local consequences as a result of this drought. Dolphins were dying in many of the rivers, wildfires, crop production impacts, et cetera. And if we look at changes over time in terms of the air temperature from July to February from NASA GISS, we see that the 2023-24 air temperatures were just off the charts. And, I'm already starting to worry about the next El Niño, which could be a +3 degree, Celsius temperature anomaly. So the take-home message here is that due to increasing climate volatility, when you factor that in, effectively in Northern South America, we're going to reach a +3 degrees Celsius, warming within probably the next 10 years during the next strong El Niño. So we have to think about that and factor that into our thinking about climate change. So the center really does a ton of work developing high resolution data sets that have been designed to work in the global south. One of the mainstays of that work are 1981 to present thermal infrared geostationary satellite observations that give us information about precipitation and temperature at local scales. We work a lot with station data, which is unfortunately a declining asset in many parts of the global south. We have less access to it, but we use everything that we can. And we work closely, we develop and we use heavily high resolution climatologies. And those are really important, if we're gonna think about where people are exposed to extreme precipitation or too low precipitation or really high temperatures, having an understanding of the background climatology really makes a big difference. And then finally, the fourth piece of the puzzle that we use are climate model reanalyses and projections. And all of these sources of information have limitations, but by blending them, we can create good products that are widely used. Our precipitation data stream is really well developed. We're putting together temperature products, but those are newer and less well established. And I think that kind of represents in many ways, kind of the state of the field. Here at the center, but just sort of across the world, the early warning community is much better at tracking the impacts of precipitation deficits than temperature extremes. And so we're going to spend some time talking about temperature extremes. But first, I would like to say that the Famine Early Warning System Network is a really great example of effective harmonization, where earth scientists, a multi-agency, work closely with food security and market analysts, herd dynamic modelers, to translate earth science into assumptions about future food insecurity. And the framework that FuseNet uses can be described by this livelihood zone diamond, where you take geography, markets and trade, production information, and then that's translated by food security analysts into assumptions about household level food consumption. And so it's, you have things going all the way from global information like El Niños and La Niñas down to local weather, extreme precipitation, extreme temperature, precipitation deficits, which then end up being translated into assumptions about whether people are going to have enough food or not. And so, even though I suppose a lot of the work that I do would be top down in terms of the conversations that we've been having in the last couple of days, it has been co-developed in collaboration with end users. So, if we want to think about an Earth system framework for temperature-related shocks in a warming world, I think it begins, again, with this idea of having increasing climate volatility, more energy moving through the system, warmer temperatures, which are going to increase saturation vapor pressure. That's the amount of water that air can hold when it's at 100% humidity. And one important risk pathway associated with extreme temperatures is that when there are rainfall deficits and warmer air, the air can basically draw more water from the stomates of leaves, which causes the plant to experience stress, and that can lead to irreversible damage. And so this is something that has received a lot of attention, in data-rich areas like the Western United States, but relatively little focus has been paid on that, at least in a sort of actionable, operational way in the global South. And so a kind of unfortunate example of that, or maybe perhaps tragic example of that, is this map of air temperature anomalies over late March and all of February over Southern Africa. This is what we're looking at now in FuseNet. We're seeing these really incredible air temperatures associated with a flash drought, and we're very concerned about it, but we are kind of grappling with how to translate that into quantitative impacts in terms of food production and income. So that's where we want to try to do better. Another, I think, even bigger gap that we're working to fill is trying to evaluate rapidly humid heat shocks and how they impact labor and health. And Cascade talked really about this yesterday. What I'm realizing is that in terms of our early warning systems, we really have very little capacity in this area. And we know from the research that extreme humid heat is related to stunting, wasting, low birth weight babies, reductions in labor productivity, increasing energy costs associated with air conditioners. And I thought I would just sort of motivate this with some experimental results. This is our new experimental wet bulb globe temperature monitoring data. I'm showing here monthly standardized anomalies for September of 2023 The El Nino has risen, and we have really extreme wet bulb globe temperatures over much of the planet. And if we zoom into Central America, we can see, at least according to this still experimental data set, that for the whole month, things were incredibly warm over much of Central America and Mexico. And if we, zoom in further to coastal Guatemala, we can see that these wet bulb globe temperatures on average for the month were incredibly hot. And I think that the food security monitoring world, anyway, does not have a good way of rapidly incorporating the impacts of those extremely wet and humid and hot conditions. So there's a gap here, and we need to work together as a community to fill that gap. And I think that would be some really important work that we do going forward. So just as an example, this is my friend Mario, who works with us in Guatemala City. And, he has been telling me for months that it's really hot in Guatemala. And until I really pulled this data yesterday and looked into it, I didn't really appreciate what he was saying. And, I guess I bring this up as an example because within the FuseNet community, we've gotten really good at understanding what a bad rainfall deficit is in terms of impacts on livelihoods, but we're nowhere near to that point doing the same thing for really hot, humid conditions. So last couple slides, I'm going to show projections from the data set that Cascade introduced yesterday. This was led by Emily Williams. These are high resolution temperature projections and observations. So this map is showing the average number of annual days greater than 30 degrees Celsius in terms of wet bulb globe temperatures. So, the light blue and red areas are higher risk. And you can see that, this is tends to follow low-lying areas along the coasts and rivers. And if we make the same map for 2050, based on the shared socioeconomic pathway 2.45, a kind of moderate, very likely warming scenario, we can see really big increases across the Sahel, East Africa, and large parts of Southern Asia. And, many people have presented similar results in the past. I think what's, valuable about this data set is its resolution. And, we really see that a lot of people are going to be in harm's way. So I think, we need to keep building out the science to understand what the impacts of this is going to be and to assess where those impacts are. And a different talk could focus on building out early warning systems and adaptation strategies. That's also important. So we're also working to understand dry heat risks. And so we can measure those with vapor pressure deficits. And so this is showing a map of the observed number of days per year with vapor pressure deficit values of greater than 3 kilopascals. So this is a measure of extreme aridity in the atmosphere. And of course, like the Sahara jumps out. And if we, again, walk forward to 2050 and look at how things change, we see a big increase essentially in the arid regions across the Sahel and parts of Eastern Africa. And surprisingly, even in places in India. And so this is, another form of risk that is increasing, and it's going to be related to desiccated rangelands with more rapid senescence, longer dry seasons, decreased crop production, increased vapor pressure deficits early in the season and make it hard for plants to get established. When there's a dry spell like we saw for Southern Africa this year, it's going to intensify those shocks, and it's also going to be associated with reduced water availability. And of course, many of these regions in West Africa and the Sahel region, are already facing conflict. So if you just kind of summarize some of the big points, carefully stacking multiple sources of information can help overcome data scarcity. Groups like FuseNet demonstrate that effective cross-disciplinary, cross-scale harmonization is possible. More work needs to be done to monitor, anticipate, understand, and mitigate temperature-related shocks. And I think an effective Earth system science assessment of climate change sees more energy and water moving through the system, not just a slow change in mean temperatures. So that's it. Thank you very much.
Thank you, Chris. It is amazing to see your center contributes this important global data set that are high resolution enough that you can actually utilize to study the impact of climate change at local level. Thank you for your presentation. Now we move on to the next speaker, Dr. Ali Musavi. Dr. Ali Musavi is an associate professor of civil and environmental engineering at Texas A&M. And again, I remind you to note your questions and maybe put your question online and we will get to them afterwards. Thank you, Ali.
Thank you so much. Can I control the slides from here? Yeah, perfect. Hi, everyone. My name is Ali Mustafavi. I'm an associate professor in the Department of Civil and Environmental Engineering at Texas A&M. In my talk today, I want to focus on population movement and population activity aspect of the interplay between climate hazards, climate change, and migration, with an emphasis on location-based data. In my talk, I present a couple of studies from my group in which we leverage location-based data. I introduce them what location-based data is, and we leverage them to understand human interaction with climate hazards, and use these studies to motivate a discussion on how we can use location-based data for higher resolution evaluation of the population migration in the future, and what type of challenges we face and what opportunities exist. So to begin with, I introduce what location-based data is. These are data that are sensed from our individual cell phones and record our positions and movements across, all daily activities that we do. And these are embedded through different applications that we use on our phones, and also different capabilities that the navigation systems have. And over the past few years, especially during the COVID, this type of data received a lot of attention from scientific community in terms of understanding people's behavior during crisis. And for COVID, this was used for empirical epidemiological models to evaluate the risks of a spread of COVID at early stages. Then it was used for evaluating the adherence of different populations to non-pharmaceutical interventions, shelter-at-home orders, etc. And in recent years, it has also received attention applications in evaluating population response to climate hazards. And the way that these studies have approached this location-based data is based on patterns of population activities. We can evaluate where people's visit during normal times, during crisis times, and by evaluating the deviations and fluctuations in these visitations and mobility patterns, we can evaluate the impacts of climate hazards on people, both in the short term and long term. So the first study I talk about is what we did on hurricane evacuation monitoring in the context of Hurricane Ian. There was an extensive evacuation zone order for Florida when Hurricane Ian happened, and using location-based data, we looked into evaluating patterns of evacuation. And we define evacuation based on change of the home CBG of the users. These are all anonymized location-based data, so very privacy protected data that all aggregated at the block group level. So we cannot track individuals at where their home location is, but we know which block group they live in. And if the block group has a certain number of residents or less, the data is scraped out. So this is very privacy protected, but based on the home CBG of the individuals, we can track changes in the places that they stay overnight, and we develop methods that we can detect when individuals evacuate based on when the evacuation orders are made, and evaluate the evacuations in terms of the not just whether people evacuate, but also how proactive they were in terms of their proactivity. So the plot on the right shows the counties in Florida that were more proactive, that they made evacuations more closer to the evacuation order time, and the ones in blue are less proactive, which are the areas that stayed more put before they decide to evacuate. And the important use case of this data is it's in near time, and by near time I mean the data of yesterday is available today. So even before a storm or hurricane lands, we can know which areas have evacuated and which areas have not evacuated, and look into the trends in these evacuation patterns. We can also look into relocation of people, not just evacuation, whether people decided to go back to their communities after a storm event, or they decided to relocate because their homes were damaged and decided to leave the communities. There are some challenges in that regard. So I talk about them in the challenges a slide later in the presentation. But as you can see, the data provides daily evaluation of the evacuation patterns. The line over here is the time that Hurricane Ian landed. The date of September 23rd is when the evacuation orders were put in place, and we can see different areas had different rates of evacuation, and the rates continued because some people moved out of the impacted zones because their homes were impacted, etc. As I mentioned, we can evaluate these behaviors at the scale, at the block group scale, and associate these block group activities with socio-demographic characteristics of communities, like the income and racial characteristics, and then evaluate, for example, the disparities in ability to evacuate, and also relocation of different areas impacted by the hurricanes. And as I mentioned, the potential of this data, especially for the impacts of hazards on communities, is to evaluate to what extent we can examine the impact of hazard for people to migrate. So when an area is impacted by floods, by hurricanes, by wildfires, we can evaluate the long-term trends in terms of the change in the residence of people, again, at the block group level, and evaluate the impacts of these climate hazard events on the relocation of people in longitudinal studies, with some limitations that I will mention later. And another benefit of this empirical observational data on human activities is that they, in some sense, defy some of the simulation and model-based patterns that we see. For example, in terms of the evacuation modeling, we have seen that the actual patterns of evacuation behavior do not show any consistency with any of the agent-based models that we have seen reported in the literature. So as much as colleagues in evacuation modeling community did try to capture behavioral elements, when we juxtapose them with what happens on the ground with observational data, we see disparities. So this raises another, a question about the ABM models and other types of model-based human migration models that we are using, and whether we can validate them or at least improve them with location-based data, with longitudinal movement analysis. That was the first study on climate hazards and population response. In the second study, I want to provide another perspective, which is how we can better evaluate human exposure to hazards using this location-based data. In this study, we provided a shift in perspective in terms of evaluating population exposure based on just the place of residence, but focus more on their activities. So using location-based data, we evaluated the patterns of population activities and where people visit during their daily activities, and to what extent the visits they made in different places, the work, grocery stores, etc., are located in flood-prone areas. So we determined or defined a metric called life activity flood exposure, which is based on the amount of time a user spent in flood-prone areas, including their place of residence and also the place of their work and all the activities that they do. And the amount of time is the number of minutes in a week that a user spends in flood-prone areas divided by the total duration of a week. And based on that, we can have population level measure of flood exposure, which kind of provides us with a sense of where if flooding happens in this community and all these facilities and workplaces that people visit in their life activities are impacted, how much population are impacted. So this provides a shift in focus from just place exposure to places to exposure of people. Another new perspective that this kind of analysis provides is what we define as latent flood exposure, or exposure of people who do not reside in areas that are considered to be flood prone. So their place of residence is not in flood prone areas, but the places that people work and visit are in flood prone areas. So this is kind of latent. We don't consider them in evaluating the flood exposure of people and how much that will impact their post-hazard decision to relocate and migrate. But this is an important aspect, that if somebody's place of work or a place of worship and other places that are important for their lifestyle is impacted, that will impact the flood impact on their life activities. And with that, we can have more quantified population-based metrics for exposure of populations to flood events. Here are some examples. We looked into various coastal areas in the US and metropolitan areas. Here we can see, for example, in San Francisco, only 6% of population life activities are in flood-prone areas, and compare it with, let's say, Orange County, which has 38%, with Santa Clara, which is 53%, and Miami-Dade 86%. So here we have more precise measurement of how much population activities are impacted by floods and are exposed to flood prone areas. And this also provides an opportunity for us to compare across different areas. And for longer term analysis, we can see how changes in climate exposure and changes in population level exposure to climate hazards will lead to movements of people. We heard some really interesting points during the previous presentations on how much the experience of floods or experience of hazards will motivate people to relocate. And using metrics like this, we can look into block group level, evaluate how much life activity flood exposure or life activity heat exposure they have, and then track that over time and see if that has increased. And based on that, look into relocation and see whether there is a relationship with the relocation and the increase in the life activity hazard exposure of population. Again, to provide more observational evidence about the relationship between or the interplay between climate hazards and population movement and population activities. And the last part, I will be quick on this one. This is kind of similar like to the flood life activity flood exposure, but more on other aspects of climate change impacts. We know climate change will change the environmental hazard exposure, such as air pollution, urban heat, exposure to toxic sites. And we quantified population level exposure to these hazards, again, using the same location-based data and how much people spend time in areas with high hazard, high heat hazard, high air pollution, and high toxic sites hazard. And based on that, compared disparities in the hazard exposure in all the coastal areas in the US, and similar to flood example, we looked into the latent exposure. And if we do this on a longitudinal basis, we cannot go back, unfortunately, because this type of location-based data has been around recently. So the farthest we can go is a couple of years back. So we cannot go 2000 until now. The latest we can access is 2019, 2020. But what we can do is from now on, if we can have quantifications of these measures and similar measures over time, then we can have observational evidence about the extent of population exposure to climate hazards and the relationship of that with the displacement and migration of people over time. So I skip that and jump into some of the challenges that exist. So one of the main challenges for more longitudinal studies is because of the privacy protection, the organizations that provide this data of course, anonymize the data and associate random IDs to different users, and we always aggregate the data at the block group level. So this has some limitations in terms of longitudinal studies because every 6 months user IDs change. So for example, we wanted to look into the impact of hurricanes and floods on long-term relocation of people. The limitations we had was the user IDs changed. Therefore, we cannot see whether the block group of a user changed. For 6 months or so, it's fine. We can see after an event for 6 months whether we have a relocation, but not beyond that, which is a limitation. But that can be done, I think, with some protocols and some, memorandums of understanding and agreements that researchers can have access to data for longitudinal studies so that we can evaluate the long-term changes in population activities and exposure and migrations, especially after climate hazards. We see those frequently, wildfires, floods, hurricanes, storms. If we can have some sort of agreements with the data providers that we can have long-term tracking of population migration, that I think provides tremendous benefit, both in terms of improving our computational models like APM models, but also providing observational evidence at a resolution unprecedented. So it's at the block group level, at the individual user level, and we can measure the association with the extent to which a person is exposed to these climate hazards and their migration, and of course, health impacts and other things. We can integrate other socio-demographic characteristics with this data. Another challenge would be the data set and that I talked about is available for US. Similar data is available in other countries. We saw that during COVID, that China, countries in Europe also had similar location-based mobility data, but the policies and regulations around these are different in different countries. So thinking about the global collaboration and global, framework for collecting such longitudinal data over time for evaluating the migration patterns and interaction with climate hazards would be important. And last but not least, biases and representativeness is an issue. So we have seen that these location-based data might not provide a complete or representative sample for certain areas, such as rural areas, versus metropolitan areas. In metropolitan areas, we see very good representativeness. So, but there are opportunities for using generative adversarial network models for creating synthetic data that we can overcome these data imbalance and bias issues that we can better use this location-based data. So I think in terms of opportunities, I summarize all of this into one that I think we have an opportunity for better, more near-time observational evaluation of human interplay with climate hazards and the impacts that climate change have on people. But we need to have discussions, frameworks, and collaborations between researchers, public organizations, and also private entities that collect and provide these data sets so that we can have the opportunity to have longitudinal studies in a privacy protected and, of course, ethical manner. So with that, I close my presentation. Happy to answer questions.
Thanks so much, Ali. Of course, it's very exciting that we can have all this data set to explore the impact of climate shocks and climate hazards at local level with this such high resolution data. But as you know, also it comes at cost. Like usually climatic data and environmental data are free, but these data sets, we need to pay for them. And that's a huge burden on researchers who want to utilize this data. Our next speaker is Dr. Deborah Bach. Dr. Bach is a professor of public affairs at the City University of New York. Thank you, and I welcome you to present your work.
With apologies, somebody always has to forget to unmute, right? Okay, I assume you can see my presentation on the screen. Yeah, great. I can see that you can see it. Excellent. Thanks for having me. I'm sorry I missed I missed all of yesterday's conversation. So I'm sure some of what I'll say is redundant, though I think hearing what Ali and Chris just presented, that this is a third perspective to add to the mix. And I hope it reinforces some of what you heard yesterday and adds to it. So as we all know, right, we have there's a lot of uncertainty in our future, but there are a few certainties, and I just want to start with what those are. And I know that the title of this workshop has migration in it, but the demographic futures that we can be really certain about are that the future world is going to be urban, more urban than it is at the present time. And the bulk of that future population growth will take place in the cities and towns of Asia, Africa, and Latin America. We don't know whether that urban future will be increasingly vertical or more expansive on the periphery of current urban areas, in totally new towns or small villages that will change into towns. So we don't know that, but we do know we're quite confident that it will be more urban. And this is really important with respect to migration, which I'll get to in a minute. We also know that the future of the world is increasingly aging, and the simplest way of thinking about it is that a greater percentage of the population will be old. Here's a population pyramid, which shows blue males, red and pink females by age and sex. And this is China in 2010 and China as estimated in mid-century. And so as you can see, there are more older people. And this is happening around the world as we speak, including in countries that just recently had pretty high fertility, such as like South Korea has gone from one of the, from a high fertility country to one of the oldest, with a country with one of the greatest, oldest shares of population in just a matter of decades. On the climate front, as everybody in the room knows, we're going to be, hotter, stormier, both in frequency and intensity, more sea level rise and flooding, fluvial, as well as more drought-prone areas. And the geography of exposure will change. That's important because we probably don't do the greatest job of projecting that in the future, as well as understanding the impacts of those future climate will depend in part on the demography of place. So I want us to connect these things. And the bulk of the slides as I go forward are going to talk about migration, but just as a general rule, where do we get demographic data from? We typically get them from censuses and surveys. And in many countries, those surveys are actually substitutes for a strong statistical infrastructure where censuses aren't in place in a regular way, such as in lots of parts of Africa, or they don't have a frequent census. So the demographic change outpaces that which is which can be evaluated through a census. But also we have lots of surveys that have deep thematic inquiry. We have a health and retirement survey. That's a global initiative. We have living standard measurement surveys. We have all sorts of surveys that also offer demographic and socioeconomic look in, views in, and those are intended to have deep thematic inquiry that we would never really expect to get with the census. I mention these things because they have different frames for how we go about collecting information and what they represent, and how they can be used when integrated with climate and weather data. So demographic data also come from administrative data, such as vital registration systems and many other types, like in the United States, people who have studied migration. I'm sure some people in this room have used the IRS, the Internal Revenue Service, tax records to look at tax filers and how whether the location of tax filers has changed between annually, and pair that with climate events. So so these are all rich but limit data sets with limits. Important to recognize that the resolution in spatial terms of these socio-demographic data set tend to be what most people in the room would consider coarse to moderate. So definitely not like what Ali was just showing us, where he has person-specific, basically agent-specific information. By coarse to moderate, I mean, we might, the geographic identifier associated, like census aerial units are blocks, but of course we all know that blocks and even block groups are thematically thin compared to the larger units, the tracts, counties, and so forth. And our survey units, often in some places in the world, we have enumerator area information, like location. Sometimes it's there's intentional noise introduced into them so that they can be, which is an issue for also data integration, but they're also often regional in scale. So a lot of these data sets are like subnational regions 1 and 2, levels 1 and 2. They're not very finely resolved. The format of such data sets are often tables or vector polygons and vector points, which present for some users quite a bit of limitation on using with the format of climate data, which is often raster, as I'll get to. The temporal resolution of these data sets is really disappointing if you're a climate scientist and you want to use these data and you want to know about an event that happened yesterday or one that's going to happen, in like the mid-year, in an off year of a census or survey. Census and survey data are either they're decadal or annual, but rarely are they much more frequent than that. And very, very few of these are annual data sets. And finally, these data aim to be representative. So if you use a sampling frame to collect data, for example, as is done with our surveys or surveys that are often derived from censuses, like the American Communities Survey, they aim to be representative of the nationally representative or subnationally representative, but usually not representative of a flood zone or representative of a heat zone, someplace that could be delineated necessarily by a climate event. Climate data, in contrast, just briefly, they're model data, they're satellite-based data, Earth observation data, or stationed, and maybe increasingly less so in the future. The resolution of these data are often very fine, but also climate models are coarse. So there's a wide range. The format is raster data, which is unfamiliar to many people in the social science community. So if you're looking for partners, you'll have to start by discussing data formats, sometimes points, sometimes tables. The resolution of a lot of the climate and weather data, flooding data, is like hourly. I know there's an interest in sub-hourly data, for example, for some kind of flooding data, or maybe annual data. So these data are really, the temporal resolutions are really much different from one another. And often these data sets that are geographically oriented, they aim for spatial completeness rather than a sense of they're not sampled, and they have a different orientation that way. So, and in fact, if you collect it from particular locations, there may not have been sampling. It just might be they are the locations, it's complete in that location. So these things impact the way data sets can be put together. I'm moving on to discussing data about internal migration in particular. I'm talking about migration that happens primarily within international borders. International migration grabs a lot of the headlines, but internal migration is way more common, and it is definitely where we will see most of the migration that results from climate stress and weather events, not international migration. It's also a necessary ingredient to understand city growth, which, as I mentioned, cities are where a lot of the demographic action is at in the next in the coming decades. So important for us to be able to say something about this. So if we have climate migration, if we expect climate migration to be on the rise because of climate stress and hazards, we should be looking for better ways to measure and identify city growth and where people come, both origin and destination, where they're coming from and where they're going to. So a little bit more about migration measurements. There are many standards, like within the census world. I'm going to talk a little bit about census and surveys, and particularly the demographic health surveys, just as one example. There are many standards. There's not an official standard on how internal migration should be measured. The IPAMS collection at the University of Minnesota harmonizes the data within a certain set of best use principles, but as a consequence, they get rid of a lot of, like, every census may have its own information that might be there may be origin destination information that is very uncommon. So some countries will have it, most will not. There may be questions on reasons for migration with tabulated responses, climate usually not being one of them, but maybe something to do with lost livelihoods. So so those kinds of questions are never in the harmonized data, but they are often in the unharmonized data. But also there are limited studies on comparing the prevalence of internal states in-migration or urban immigration across a large scale of countries. So we don't scale many countries, so it's a little hard to know just how they compare. There's also, there's very natural variation in migration measures. There's a lot of ordinary migration and mobility. And so if we use a specialized survey, to get at some of these things, we may be able to address some of the multifaceted nature of migration, that which may be occurring due to some climate event, as well as that which is not occurring to it at the same time. We're looking at those things in parallel, but lots of migration is very, very, it's built into, for decades has been built into the life cycle and the household strategies of individuals around the world, sending somebody to another location, sending a member of the family to, some members of the family work. It's a family strategy or a household strategy in many places. But in the interest of time, I'll put that off for later. And then again, there are varied sources of migration, and different migration questions are asked across these data sources and countries, or even times. Countries change the way they ask about migration. So I'm going to compare these two surveys for you, for these two approaches, censuses in general and the demographic health surveys. The censuses, they're pretty reliable for pop projections, which is important. Of course, we saw some, Chris mentioned some stuff about projections as well. And if we want to project these things in the future, you prefer a full enumeration of the population. I should also add that migration, unlike fertility and mortality, the hallmarks of our of demographic forecasting, migration doesn't share the same sort of momentum and patterns that we would see with those other two characteristics. Migration flows are specific between administrative units, and that geographic detail on residence changes sometimes there, sometimes not. And then historical trends of internal migration, it's usually fixed intervals between the census and longer periods of data. So you're really stuck in the time horizon. The demographic health survey captures more population dynamics and more local moves, potentially because they use an any move question. They provide information for understanding flows between rural and urban areas and towns. And it's available for African countries where historical censuses are largely absent. So that's just an interesting feature. When we look at, when we ask questions about migration, just even in the, apart from climate, we assume that most migration is within rather than between country. We ask who migrates. We assume it's those who are better off from available evidence. We assume those who are able, those who are better off, young adults, part of a household, not necessarily all of the household, and rural dwellers seeking urban opportunities. Those that you see in bold are ones that we can actually examine with most of the data. Those that that aren't, we can't. And it may also depend on seasonal versus permanent migration. Those are very, very hard to get at with any of the surveys, survey or censuses that I'm talking about. And And certainly most have not been paying attention to using these data with climate change or population aging, partly because we assume migrants are young, and we see evidence that they're young. So just to, again, one last total deep dive, migration status measures. Here's just so you see, these are the questions that are used to enumerate a question on migration. Where did you live 1 or 5 or 10 years ago? That varies. Huge variation in the range of responses. It can be place specific, or it can be province names, so those have to be recoded. It could be classified within this province, from another province abroad, from another city, town, or the countryside, or simply urban or rural. Another question that's sometimes asked, how long have you lived here without interruption in this locality, followed by where did you come from? And as above, huge range of responses. Then there's a different type of measure, which is just asking about previous residence, which is where was your previous residence, sometimes followed by when did you live there? And if it's not followed by that, we can't measure migration. So these produce an enormous variety of measurement constructs. And I'm going to pass this slide. So the only thing I want to point out here is that so this just compares them, is that the bounding units for these data sets, the censuses typically use major administrative units. Some use minor administrative units. The demographic health surveys do not ask that. All they know is whether the migration origin is a city, town, or a village. It does not know the province even from which that city, town, or village would be located. This is an out-of-date map showing, but the 3 different colors here represent that you can, and in this case, I was trying to look at urban in-migration rather than all in-migration, but the map with all in-migration adds a couple countries, notably China gets added because, the 3 different colors represent estimates that we can derive from census collections through the IPMS data set, demographic health survey collection, and green represents both. So you can see that there's and the global north countries are omitted from this particular project, and most of those countries have such data, some kind of data through their national statistical offices, so they could show up or through the IPMS collection, but they weren't here. And the hatching just represents how many years we have. So all of this is to like the multiple versus single years. All of this is to say that to get a global picture of this phenomena with this very broad strokes, we have to patch things together. Here we see the solid line is a 1-year migration estimate. This is a proportion in migration because we only observe people upon destination, not at place of origin. So we know among people at place of destination, did you move here? Did you migrate between major administrative units? This is shown just for Uganda, and this is shown for districts. And we see this at this is on the x-axis, we see age, and at 1 year, it's pretty flat, both the level and the age distribution. And then at 5 year, we see a jump. We see much more clearly that migrants are younger. And then at 10 years, we see that the levels go up. So really, the year at which you are able to evaluate, this metric is very important. There is disagreement between censuses and DHS. DHS typically reports higher levels of urban immigration, probably because it relies on any migration measure, which is probably more important in an urban area. There's a lot of historical evidence that suggests people move a lot within cities, especially migrants. They come to one place, they go to another place, they move again. And therefore, it captures that. But there is very much agreement between both censuses and the survey data in the age pattern. So this is showing different ways of measuring it. The green one, though, is based on the survey data, and the pink ones are based on the census data. There are some concerns that the surveys may lead to selection bias and their sampling universes differ because the sampling frame for the demographic health survey is primed at getting women of reproductive ages and their families. So it may be that they miss other kinds of households, like including people who might live in, say, group quarters that are like labor migrants, for example. There's also on census non-response, particularly some types of migrants don't want to be counted, even within national borders, especially. There's the any versus administrative one bounding box for where did you move from? Did you any move versus did you move from a major administrative area? And also the size of the bounding unit, which is, I think, the next slide. this is just to compare admin level 1 for India and Cambodia, both which are reported in the census. It's just important to note that the size of the administrative unit in India is 13 times the size of the major administrative unit in Cambodia. So just those sizes alone may produce different types of measures, like what they can actually capture differs because you have a lot more land area and people, but in some of them than others. And here we see this is sorted by descending area, but it just looks at the average. It looks at the distribution of the migration defining unit for major administrative unit across many countries. You might wonder, how far is migration? So when we ask between minor administrative units, and this is based on censuses, we see the green is showing us those are countries that ask between minor administrative unit, not so many. There we go, sorry. Then we see between major, those are all the orange ones show up. And then we add on to it from abroad, and most of them ask about from abroad. And you can see that the from abroad, the red little sliver there, is a very small fraction of the in-migration. So I encourage us to really take, try to be thoughtful about what we can do to improve our migration statistics within national borders. When we use the demographic health surveys, we can ask something about in-migration to cities. And here we see where have people moved from. The green represent rural areas, the orange represents towns, and the red represents cities. So most of these countries are experiencing migration within towns and cities at this point, and this is already old. And so I would expect this particular slide is already old. So again, we have to be willing to pay attention to migration between cities and towns, and also to pay some attention to specific cities and growth of those cities as part of the question about migration. Let's remember that migrants often end up in more climate impact areas that may be at risk of greater climate hazards when they're in place of destination. So these kinds of where they end up matters. An alternative where the data are strong, and here's an example from Mexico, shows that moves between major administrative areas misses a lot of moves within and to urban areas. So, but if you have municipality level data, and increasingly censuses do, you can generate through just a simple calculation of centroid, and the origin destination, you can calculate actually the distance of the move. And this is important because there's an increasing body of evidence, a lot of it from the US, but not exclusively, that moves, disasters, and interesting on the last presentation, that we see like disaster response migration. So moves are pretty much near, sometimes they're near, and they amplify already existing inequalities in communities. So there are some studies showing after Hurricane Harvey, I believe, in Houston, and a couple others that's showing exacerbation to inequalities from moves, and that moves are almost as near as possible, which also has implications for who's in the path of the next possible storm. For example, these are often coastal areas as well, so sea level rise and the combination of sea level rise and coastal storms, so that people move, stay in the same labor market, but they don't move very far. And I should say that a lot of the studies that have provided evidence on this are either administrative or event-specific data, very specialized data sets, not the kind of data sets that I've just discussed, because the data sets I've just shown, which are available in so many countries, are not really well suited for this. I'm almost done. Just to point out that big and new data, some of which we just saw, but we have cell phone data, Facebook data, Facebook advertising data, and I should say Facebook advertising data is probably more interesting to use in this context because it's not dependent on who has Facebook, but who's on the advertiser side of it. And there's a very interesting study of colleagues out of the Max Planck Institute that tries to estimate out-migration from Puerto Rico to mainland US, combining Facebook advertising data with ACS, American Community Survey data. And so that's like an interesting use. And then also we have administrative data. I mentioned the tax IRS data for the US and vital registration data. One thing we need to know is that the universe, we always need to ask, who do these data represent? Those with cell phone or those who use Facebook, and who are those people? Or tax filers, for example, the very poor do not file taxes. Undocumented individuals may not file taxes. So if we're trying to get a vulnerability in this, we may be missing out. And they also, so and the last presentation again, it showed, I have some questions, maybe we can address them in panel, but like when we know something about an agent, the question is how much do we have to infer about the characteristics of the agent from an ecological zone rather than from individual information. Of course, always if we can use these data and blend them, as we just saw, using them in before after studies is very helpful. And ideally coupled with other anchor data helps us to understand how to place these data and make good use of them, I think. So I want to end with a slide to suggest that this is the reports that come out of the National Academy sometimes make their way to national statistical offices, and so I think it's an interesting thing to think about what recommendations could come out that might improve migration measurement. It's more delicate and more complex than other demographic events, but I think it's really, really clear that there's a need for it. Even apart from future climate change, future demographic shifts will be oriented around migration. So national statistical infrastructures have an incentive to think hard about better measurement. And new data is great, as we just saw. But again, partnerships would really help understand it. And also using such data in enclaves is really important, using as well so that the privacy protection can be retained. And finally, engagement with those national statistical offices is really important. I think they typically want to hear from a wide range of stakeholders like us. So I think this, people in the room have an opportunity to be heard if they want to be. And that concludes my remarks.
Thank you so much. Thanks for your very insightful presentation on different types of data that is available and also issues that we need to consider when we utilize and aggregate this data set across scale for study migration patterns. So we have a number of questions online, but I was wondering if there is a question in the room for all three speakers, any of them. Yes, please.
This is for Ali. I've really enjoyed your talk. Except for it was disturbing to think about how your data suggests that we've got errors in the agent-based models. So I wonder if you could talk a little bit about what your data revealed in terms of the errors and what we might think about moving forward when we use those kind of tools.
Sure. So just for clarification, our data was not compared with ABM models for migration, but it was juxtaposed with ABM models for evacuation. So in that sense, what we observed was there are different types of behaviorally based ABM models for evacuation analysis, and almost none of them could capture the actual evacuation patterns of communities across different events. Okay, so that raises a question of to what extent, those behavioral based, which were based on surveys, capturing, previous hurricane experiences, risk perception, all sorts of things could be used for planning for evacuation. And I think my own perspective is the combination of the both. We can use location-based data to improve our ABM models, but again, each event is unique. Each event has unique characteristics. I think the good thing is with this location-based data, we can have very precise measurements of the actual behavior, in this case, evacuation. So those are more, this can complement like the survey-based methods for capturing the behavior. Say that, okay, so respondents of the block group from this area mentioned that this would be the way they would evacuate or they have evacuated. Now let's juxtapose it with actual behavior during the hurricane and see to what extent they confirm or contradict and how it will feed into the ABM models. I think similar considerations probably would need to be discussed when location-based data is used for ABM models for migration.
Just seems the error when you're comparing them could really tell you a lot about what the ABMs are missing. So I think there's a lot that can be learned from that comparison.
Exactly.
I hope you continue along that line.
Absolutely.
Thank you. Other questions? Amir.
Great presentations. We heard about large scale global climate, high resolution climate data, and high resolution when it comes to climate is much, much coarser than location-based cell phone data, right? It's all relative. And do you see opportunities to bridge the gap? Like, for example, a question for Chris, how does local scale cell phone data can help you, and the other way around for Ali and Deborah, how does like this climate data can help you in your research? What are the opportunities in between?
Yeah, well, sure. Maybe I'll just answer quickly, Amir, and say that there are studies that have been that are being done using cell phone data, for example, from Somalia and Zambia, looking at where people are moving that are really useful to food security monitoring. And I think there's really great examples of CHIRPS data being bundled with demographic and health survey data and being used to assess health impacts. So so there's lots of opportunities, I think, for collaboration going forward. Over.
I think we are always, when we intersect these different data sets, we are bounded by the common denominator of the resolution. Like, if we have resolution of, let's say, climate hazards or climate projections at certain scale, then we ended up aggregating the movement data at that scale. Or at least if we don't aggregate, for example, let's say the climate hazard data is at the coarser scale and location-based data is block group, we should assume that all the block groups within that coarser scale have the same hazard. That kind of prevents our ability to look at the variations in climate hazards or future climate projections and have more meaningful comparisons between different levels of exposure to those climate stressors and population activities. So I think, and also demographics, one of the limitations we have is because of the privacy protection, which we really appreciate and I think it's important, we don't have the demographic characteristics of individuals, and we have to again infer those from the block group that they live in, which is a reliable proxy. But if we could have also demographic information associated with that, not precise, but let's say whether this agent represent let's say 65 years old or plus, or represent a racial minority or non-minority. I think that will increase the level of resolution in our findings, and I think when we intersect those, we are bounded by the common denominator.
Thank you. Other questions? Yes, Diego.
Thank you all for your presentations, and Ali, this is for you. Do you see any risks of this type of data backfiring on already vulnerable populations, in the sense that when we're transferring risk, thinking about adaptation and climate hazards, right? Insurance is one of the things that we're currently pushing, right? Could this penalize behavior that is not responding to, let's say, government announcements on evacuation notices by increasing primes, for instance? This population is not reacting to a hazard, so that population is going to be penalized price-wise, right? Or other means. Do you see any risks of this being used in that sense if it enters the market, I guess?
Of course, that's a very interesting question, and I don't think I have the answer to that. I think there are, with every new data sets, emerging data sets, there are risks and opportunities, and I think that could be one of the considerations. And we also have to think about, for example, if an area don't evacuate on time, what are the barriers, right? So this could inform evacuation planning for future events, right? Evaluating, let's say, currently we are working with other groups, including FEMA's evacuation analytics folks, to leverage this data for future evacuation planning. But from other perspective, like as you mentioned, from insurance premium, etc., that could be a potential risk. I don't think I have the answers, but I think with every emerging data set, we have to always think about the risks that they might impose the people.
Thank you. Other questions? Okay, there are some questions online. The first one is to Chris. You outlined how FuseNet offers early warning to cope with or adapt to seasonal to sub-seasonal forecasted conditions. Is FuseNet used or could it be used for policy making from a long-term projection migration standpoint?
Yeah, I think I would say that a lot of the data sets that FuseNet has assembled could really, be used to inform, long-term policy making. And, we've worked on those sorts of projects for East Africa, for example. And so, having long, high resolution, high quality data sets are really useful to, identify hazards when they emerge, but they can also be used to, look at trends and help anticipate, future risks and guide policy. So the answer is FuseNet doesn't make policy, but the resources that it's developed can be used to help inform those sorts of things.
Thank you. The next question is for you as well. I have a question regarding the stacking approach. Firstly, it's quite useful, but how can we overcome the problem of poor high resolution data or lack of longitudinal data for studying local climatology?
Sure. So, maybe we can take the example that I had in my talk of like extreme wet bulb globe temperatures in coastal Guatemala, right, which is a very small country with lots of variability at small scales. So what we do to begin with is take historical station data, which is generally there's a lot more historical observations than there would be, rapid temperature observations. And we use long records of satellite observations and elevation and combine them to make a really high quality climatology, a long-term average that says, in September in southern Guatemala, the average temperature is this. And then we use satellite observations and climate model reanalyses and temperature observations to estimate anomalies around that average. And so that, brings a fusion of these different resources in a way that does a pretty good job of, estimating high resolution variations. It wouldn't be as good as you would get from having 500 stations in Guatemala, but it does a decent job.
Thank you. Do we have, okay, there's a question in the room, Elizabeth.
Thanks. This is a really interesting presentation, and Chris and Deborah, you both really have deep expertise on these two kinds of data that we have seen a lot of scholars bring together to try to answer questions about, say, the marginal effect of a climate exposure on the probability of migration. And we have also seen that there isn't a lot of agreement in the studies that have done this. Roman Hoffman and his colleagues over at IIASA have evaluated this literature, and they show that, sometimes there's a migration response, sometimes there's not. And it seems to me that one of the things that we haven't been very good at measuring, that is the intervening variable on the ground, is the characteristics of the place that's exposed to the climate hazard and how adapted the infrastructure might be to the specific hazard in such a way that it would, intervene and affect the probability of migration. And so my question is, have you found data sources that could be combined with either the two kinds of data that you elaborated today that would help us to get at this issue of the intervening variables that are on the ground that might indicate the degree of adaptation to a specific hazard?
So I'm going to give a quick answer while Chris thinks on that. Thanks, Beth. I think that, first of all, if we just have small tweaks and we do a better job of getting place of origin as well as place of destination, we can attach some of this information. Frequently, we cannot do that, right? So, and I think, but you're probably right that some of the signals, like the migration is just one of many possible responses as well that people have. You could have, if it's a heat event, migration may not necessarily be the response. If one is not engaged in agriculture and has an opportunity to live in a place with some cooling, whether it's natural cooling or mechanical cooling, that can, mitigate the impact of heat, then, people might choose those options. So, and maybe we can get proxies of those kinds of things. But through like, income or something like, wealth bundles and so forth. But I guess I don't know of an existing data set, but I'm trying to suggest that being able to unpack sometimes these, the unharmonized microdata of the censuses really do have the origin destination pair. And that allows us to know more about climate, about the place of origin as well as the place of destination. I also, in talking about migration, we should also talk about who doesn't migrate. People who stay there in every single event, there are people who do not migrate. And that's an equally important, and maybe they're adapting, maybe they're not, and so maybe, those individuals are maybe at continued risk, and it's worth paying, giving those. I would recommend that we also use some of the longitudinal data sets that we have in our, some of the demographic health surveys are not longitudinal, right? They're cross sections, but some data sets like the suite of among older adults, at least like the HRS, those are panel data sets. And in the United States, we have plenty of panel data sets. So we know who, following people longitudinally gives us an opportunity to look at a little bit of this. Lastly, let me just add that I don't think we do a great job of measuring adaptation mechanisms, adaptation policy per se in place. That's very, very hard. So that's another, but that maybe is, and that's going at along with governance, things like that are a whole lot harder to, there are increasingly best practices and some guidelines for these, but it's not systematic in the way some of either the type of data sets that, Chris presented or that I presented have. But again, another call for systematic collections of adaptation programs or policies or initiatives would be helpful. That was a long answer, but I'm passing the baton to you.
That was a good answer. Yeah, I guess I think two comments on this topic. The first is I think that we can learn something, from FuseNet or the food security monitoring world in general, that people like me do stay away from modeling food insecurity, but rather what we focus on. So there's, basically there are many different ways for people to face starvation, right? It can happen lots of different ways. So it's a hard thing to model directly. So what, folks like me do is try to come up with good models of, proximate drivers of food insecurity. So for example, reductions in crop production and labor impacts. And, in terms of, what I presented on today and thinking about increasing humid heat risks, I think we need to do a lot of work on what increasing humid heat is doing in terms of, opportunities for local labor and barriers to local labor and income. So that would be a place where we could move together to advance in a kind of a rigorous way that would, inform migration studies, but it would be well-bounded, I think. And so I think that is something that I'm interested in anyway. And then I think another place that we could move forward, if we think about this, somebody's decision to migrate or not from kind of a Earth systems perspective, right, where we want to try to improve our estimates of the shock to the system, but then you know, a household is going to have, you know, reservoirs of wealth and adaptive capacity, right? That's going to vary a lot from household to household. And so, you know, there are some innovative efforts out there. Like I'm mostly familiar with some work by Kathy Bayless and Aaron Lentz, colleagues here, who are like, you know, using remotely sensed observations of roof type to help develop really high resolution, you know, maps of poverty and kind of the idea of adaptive capacity components. So.
Unfortunately, we have to end this session. We are already over time. Thank you to all the speakers. And also I thank you all for your time and attending this session. We're going to take a short break and we'll be back at 1. Okay, thanks.
will join us to share relevant funding opportunities. Please.
Thanks, folks. So first, I just wanted to start by thanking Amir for chairing such a successful workshop. I think we can do a round of applause. And thank you to the other committee members for designing such an insightful gathering. It's been really humbling to work alongside you these last few months and learn about your expertise as well. Also, we'd like to thank the speakers for sharing their work and the participants for your thoughtful questions and insights. And a huge thank you to the National Academy staff, Lily, Maya, Miles, and Katrina, for making sure this all went so smoothly with the hybrid options to engage that probably allowed many more people to participate. So first, I'll start us off. We're going to just kind of we're going to run through a couple of the points. There's just one point that was emerging that I wanted to highlight to the group, and then Shayna will do the same, and Beth will do kind of an overview of potential next steps, and we'll end with Laura talking about some of the NSF programming. So first, the intent of this workshop was to bring together an earth science, systems science perspective to climate change and migration. And we've heard about climate migration scientists, from climate migration scientists about data gaps in their particular fields, as well as opportunities for convergence of some of these methods and how that's already being done in many instances. To answer the questions, the who, what, when, where of climate and migration. We saw and discussed models, but again, both earth as well as social science models, and I'm using that term a little bit loosely here, that answer many of these questions with varying levels of certainty, which just came up in the last session. And of course, that uncertainty was really nicely disclosed by all of our presenters, according to the standards of their fields, the model spread, error, et cetera. We've also identified stakeholders who are producing these models, a lot of folks in this room and participating online and beyond. And we have a better understanding of climate migration as a global political priority. That's in part just demonstrated by the convening of this workshop. I've been really interested in how presenters have considered the model users. So a lot of folks in this room are producers or producing knowledge that's contributing to some of these models or other knowledge generations for decision-making around climate migration. And this goes from the generation of the research questions really across the research enterprise to what might be done with these results. And I want to just highlight some of these considerations from the speakers and participants. Lori really started the workshop poignantly by noting the need to engage policymakers to help us identify exactly what are the research questions we should be working together to answer. Justin started the challenge of inequities in data inputs that undoubtedly mask the impact of climate on the most vulnerable populations, which was a theme that we heard again throughout the workshop. Jackie spoke of the existing local and historical knowledge that could really benefit climate and social scientists as they come together to converge their methods and synthesize models for better measurements of climate need and also response. Kevin and Diana mentioned the legal implications that individuals face about the label or classification of climate migration. And I think this is a really important issue to highlight, to think a little bit more about in terms of the legal implications or the protection of international humanitarian law to folks that are designated as refugees. Also, that we talked about just this morning, the delicate nature of national migration statistics. So these are just a lot of ways the users have been considered in our discussions, but I wanted to just kind of place a name to this. There's a little adage, all models are wrong, but some are useful. And I wanted to think about the winners and the losers for these model outputs. And I'm oversimplifying this, but I just think it kind of brings out a point that I heard a lot. And basically, the models that were discussed in this workshop all have real winners and losers if taken to decision making, right? So affected communities at the individual as well as community national level, governments planning for migration flows and cross-national migration policy. I come from the humanitarian space where there's already a ton of enthusiasm to use climate models and other models with climate inputs for migration estimates, and specifically around this idea of anticipatory action or coming up with an intervention and a pre-designated threshold to activate it, basically, which should theoretically be both cost and life-saving. But we have to think about who the winners and the losers are. Should there be a false positive or a false negative, right? What does it mean to win? What does winning mean to different stakeholders and different users? If we're wrong, what happens if it's a false positive? So what happens if we predict something or we predict a migration event that actually doesn't happen? And so resources are spent or allocated. And conversely, what happens if it's a false negative and we do have migration that occurs due to climate that we're not prepared for? And I also want to think a little bit more about the risks. We just touched on that this morning as well, and particularly those that are borne by the most vulnerable communities, and as well as the agendas of the people designing the research and how those translate, how some of those biases or agendas might translate into policy. So I think our considerations of these questions will inform the design of future research and methods. And I hope I've managed to summarize this point. And I'll let Shayna cover the next few points.
Okay, thank you very much. So I've not taken maybe as thorough notes, so I'm going to make some comments, I think, based on what we've talked about over the last day and a half, and then maybe things that I would see as potential paths for us to continue these conversations, hopefully in longer term, more sustainable ways beyond what we're doing here today. And so I think initially, I mean, maybe building off of what Danny was saying, we've had a lot of conversations about complexity, right? On the modeling side, on the Earth system side, and also on the side of the human dimension. It seems positive when you hear comments like Alex made regarding, the fact that we're leading with such an interdisciplinary group, that social science is helping to really frame a lot of the conversations we're having now. But I think that we need to still do better. This is maybe a first step or first set of steps that we can take, but coming from NASA, I still see hierarchies in terms of which is better science that needs to be changed, and who does the science, which also needs to be changed. And so this means, how do we build, in our own institutions, different approaches, or simply support those communities that are already starting to think differently and make sure that that's happening at a larger scale. And so I think there is still some tension in between what we see academia and larger research institutions leading in terms of more interdisciplinary approaches, but then also how it's reinforced through maybe the grants or the ways that we approach science. And so I would say, some of the benefits I do see, say, like changing within institutions or agencies like NASA, is we're starting to roll out an Earth Science to Action strategy, which is really focused on underlining and not making it the last mile decision, this concept of societal benefit. So, ideally, we're advancing the future science missions and science approaches based on needs that are identified here today and yesterday, for example. I think that we're also starting to see greater emphasis on, which is new, I think, for NASA, but not for other agencies like NSF and others, but more interdisciplinary emphasis. Social scientists, up until a couple years ago, were still boxes that I saw ticked. I know because I'm an environmental scientist and a social scientist, and every time a proposal or a solicitation asked for social scientists, people would run to me and say, I really need you. And I'm like, why? Like, what is my contribution? And they couldn't answer it, right? It was just that I got one, I won. And so obviously, I think that there are changes that we could still advance towards. In my mind, we're getting better, but we need to continue this conversation. We need to sustain attention and also financial support for, these types of efforts. So that's one element. I also appreciated the global to local perspectives that were taken across, how we approach migration or movement, broadly speaking, as well as, where the modeling could go, where our scientific outputs and things like that could go. But I do think that, some of the conversations that we had with Mira and with Jackie could go further, meaning that Indigenous knowledge is one part of this, but we're still missing a lot of the human rights-based approaches that apply broadly to people that need to move, whether it's internally or internationally. And so I think we get very concrete stories of what this means. But when we look at issues like global policy narratives like the Global Compact, they're helping countries become more like approving and integrative of migrants, but it's not really showing you all of the human rights abuses and dignity rights abuses that are not covered by things like the Global Compact, right? So freedom of movement, this is one of the greatest impossibilities that we may ever tackle, but yet, there is an element of agency and volition, which I think you mentioned yesterday, that people need to be able to have. And this extends to things like security, right? Freedom, protective freedoms, whether they're gender-based or ability-based or language-based. It includes things like access to services, reproductive rights. We know migration is not linear, that people don't just simply move and end up at a place and they're there forever. They can go back, and it can be irregular, but it also could mean that they move for years before they end up in their final destination. And so with this in mind, there's a continuity of human rights and dignity rights perspectives that I think, we could start unpacking as well in terms of how we approach some of these elements, which extends also to standards of living, civil and political rights, equality, et cetera. And then finally, I think some of the conversations, again, really exciting to be surrounded by so many people that are thinking about the nexus between humans and their environment. I think I came out of a lot of my previous work with the UN before coming to NASA, excited about the potential of seeing these types of perspectives. But one of the things that I worked on with the UN, it was with a special, a joint unit between UN OCHA, which coordinates humanitarian response internationally to protracted crises, not to just sudden onset disasters, but also with UNEP, the environment program. And the goal was really to recognize the fact that the majority of humanitarian and development funding simply does not have an environmental marker, right? We have a lives first personality or approach to things. But what that means is that, the issues that are being unpacked across the last day and a half are sometimes missing in the humanitarian and development context, because we're seeing, you know, education and WASH and gender and things that are critical being spent and earmarked in programming for humanitarian efforts, but it's missing the environment and climate elements that are often driving or exacerbating these issues. A perfect example may be what we saw with many of the examples coming out of Bangladesh, specifically with the Rohingya camps, right? We've got a country that considers them migrants, but the UN, which, you know, obviously considers them refugees. Regardless, without thinking about the environment, the changing of the landscape to create more room for people led to intense flash floods, landslides, fires, etc. And in the UN reports on lessons learned from the work that they did there, it specifically says, we shouldn't have terraformed the land. We should have considered the environment. That's not news. But what that does mean is that conversations like these cannot happen within academic spheres alone, that we do need and maybe could benefit from including practitioners in our conversations like this moving forward. The economic sector was mentioned. Financing drives this. Development drives the decisions we're making, as do policies and laws. And so the more we're able to unpack those components, bring people and, you know, into conversations like this, I think it can not only bridge the gap in terms of the challenges that many of you identified today and yesterday, but then also help us advance the science, but also the approaches for improving how we approach climate change and migration, not just narratively speaking, but in the policies and programmings that will change us ideally for the better. And I would say, you know, I think not only do you not see programming or funding going to the programming in these spheres, but while you mentioned the intense interest in climate models, I think there's still an intense capacity gap. And so I learned this well enough in the UN, but like I still continue to work with a number of partners who are interested in it, but don't necessarily know how to institutionalize these types of approaches in the work that they're doing. And so one last thing that we have done with NASA, I think, is not only move towards an Earth Science to Action strategy, but I recently launched an effort called NASA Lifelines, which is focused on bridging the gaps between earth science and humanitarian action. And so it's one small contribution, but I'm hoping that the more we have efforts like this, bringing our communities together with practitioner communities, the better changes we can make. And I'm going to turn it over now. Thank you.
Thanks. Maya, can you put up those slides I sent you? So I put together some slides that, you know, they were not as polished as everybody else's slides who presented, but they represent some of the many threads that have come together. And I think one of the things we can all agree upon is that there's a lot of value in all of the work that we've reviewed and that we've learned from about bringing together climate exposure and human response data. But we also have identified the challenges that it represents, both in terms of, you know, getting the data at a common unit of analysis and also making sure that we're measuring what we think we're measuring. And so I want to sort of say, I think we are all fascinated by those questions about measurement and modeling, but we actually need to bring ourselves back to this question of what are we trying to answer? What are we trying to discover? And, you know, Alex's presentation this morning did a great job of saying, yeah, you know, we focused on hotspots and where these sort of sudden events are going to emerge and how we can better understand those risks in those places and what might be driving them so we can be more responsive. And that's, you know, that's one set of questions that are, I'm not going to diminish, super important, but that's not the only question. And so another kind of question that social scientists have really engaged in has to do with what we call migration effects in, selection effects in migration, which is basically identifying disparities or different, demographic differences in who migrates and who does not migrate. And so, that's a question that without the demographic data that some of the social scientists who've participated have reviewed, we're not really going to get at these deeper questions of disparities, which relates to the point of injustices, and how can we target resources for those who are most at risk of being displaced or being locked in place. And so I just want to make sure that we understand the value of the social science data for answering those very important questions. I'm gonna kind of switch topics now to look at some of the spatial and temporal data on a hazard event that produced a migration response in Puerto Rico when Hurricane Maria hit. And there was so can you advance the slide? I put together this table where I was reviewing all of the different sources of data that were used to look at migration after Hurricane Maria. And I was interested not just in kind of what questions could be answered, but also who could access this data and how timely it was. Because of course, when we look at a disaster happening in real time, we want to have information in real time to be responsive. And so the table is sort of divided by the social media and the administrative data that is available at different speeds that sort of but what you can see from this table is that a lot of that data is more timely, but it doesn't have the demographic information. And then when you get at the data that's below the black line, that has more demographic information, what you have is that it's very slow to produce that data. And it's and there are other qualities on which they vary, but I just wanted to present this table to show what some of the trade-offs are, and that we kind of have to do both things because we have many questions to answer. But if there's something that we wanted to do better, it could be to make sure that this kind of data that is both demographically detailed and population representative is available in a more timely way. Okay, can you advance to the next slide? And then this is a paper that came out of it was published in the Proceedings of the National Academy of Sciences, where it used this data, some of these data on Puerto Rico, and to look at change in the Puerto Rico population that was due to the outmigration after Hurricane Maria. And it just shows you a little bit what the different kinds of data tell you, both in terms of the magnitude of the effect, the timing of the effect. And what I want to point out here as well is that the time scale here is just, it's a little over a year, which is important, but it's not the end of the story. And it's also not the beginning of the story. And so sometimes when we think about hazards, we put it on this very short time scale because we're just thinking, cause and effect, it's very immediate. But this gets into the long histories that are so important, where I'm going to, some of the things that we've learned from Jackie and are about how deep history matters for migration responses. And certainly Puerto Rico has a long history as a sort of US territory colony that has a lot of, deep poverty and definitely is an underserved community. The setup for the crisis began a long time ago, and the failure of the power system is like a long time in making, and that really was so key to the way this change in population played out. Okay, next slide. So then I want to also talk about how I want to move from some of the empirics and the data and the measurement to thinking more about conceptualization and theory. And we've talked about migration in this meeting as if we're talking about something that we all know and understand and can and really think that we understand what we're measuring. I think Deborah's talk this morning did a good job of saying, well, look, these different data sources measure migration in different ways, and you get different answers depending on how you measure it. Similarly, Catherine Donato's talk yesterday, she gave a really good model of how migration scholars often think about migration, which is that it is a trip. It is not a person. And so a person can have multiple migration trips in their lifetime, and they have different meanings. So what I've tried to do here in this slide is mark out the 3 different dimensions of migration, which a migration trip, which include distance, how far do you move, whether it involves an international or an internal border, the duration of the trip, is it temporary, permanent? And if so, if it's temporary, how long does it last? And then finally, this issue of volition, where you range from being, completely voluntary to kind of constrained mover, moving under some duress, or maybe more duress, or maybe completely involuntary. So I've put little circles with names inside of them to show how each of these types of migration falls in, kind of has a different intersection of these 3 dimensions. And that's just important for us getting to understand, like, when are we talking about the same thing when we say migration, and when are we talking about something different? Okay, next slide. So here in the US, just to elaborate the point a little bit more about what we're seeing when we talk about forced migration, there are really different kinds of forced migration that when you look at how they're happening, they are happening with very different policy mechanisms, different types of exposures. So with the evacuation and displacement, that's one of the things that we've really been focusing on. There's a short-term exposure, people move, there's property damage, and there's policy uncertainty in terms of how to recover. And these are the kinds of events that often exacerbate inequalities. Homeowner buyouts, those are more anticipatory. They have a different kind of profile of what they look like in terms of migration, but because they happen with more volition. And, they have a different they play out on different dimensions. And then finally, the community relocations that we've heard about in Alaska and Louisiana, which again, play out differently because they also play out in a community where it's not just individuals making a decision, there's a collective that's making the decision and deciding how to navigate that. So this is just to underscore the point that migration doesn't always play out as an individual decision. It doesn't always play out as something that happens in crisis. It might be anticipatory, it might be reactive. There's a lot of variety. So, all right, next slide. So getting back to the theory, that this is a slide that's come up a lot. And I want to talk about how where I'm driving to is focusing on the meso and micro variables so that we can understand more about the selectivity in migration. Because the macro drivers are great if we're talking about, sort of a population level response to a hazard. But they don't tell us about who the winners and losers are. and who's having to move, who's not having to move, who gets to stay in place, who doesn't get to stay in place. And so getting back to this idea of, well, maybe we can all agree on a common unit of analysis of a particular place where we can hit that sweet spot of like accuracy and uncertainty, and what's available what data is available. If we find that common unit of analysis at a geographic level, it helps us to identify who our community partners would be and who the stakeholders are and how we can tap into those people who really make our work transdisciplinary and who can help us to really add information about the context and about the people who are, who are really becoming migrants or not becoming migrants. And that's where I think that's the direction I feel that a lot of our comments are driving toward. I want to, to kind of conclude, I just want to, and to illustrate this point, last night at dinner, I had a really fun conversation with Jackie, and she told me about a resource that I wasn't aware of. Can you advance to the next slide? Called the LEO Network, which is, it's the Local Environmental Observatory Network. And so I looked this up last night because Jackie had told me about this event that happened, that she was actually part of this data collection effort. So I'm not going to represent it anywhere as near as well as she did. I'm just going to point out that in Kotzebue, Alaska, Jackie's sister noticed that a lake near her house had suddenly drained. And she reported this on the LEO network. And it started off an exchange of knowledge between local residents and scientists, and to figure out what had caused this sudden lake drain. And while there seemed to be a connection to climate change, one of the things they just found is that there was a very complex chain of environmental and causes of this lake drain. And the lake, of course, is a vital resource for water and food for the local community. And so the societal implications of this lake drain were actually also more complex than any sort of remote sense data would reveal. So what inspired me about learning about this example was that even though there's not really a connection to human migration, in fact, the migration involved in here was beaver migration, beavers moving into this, this community, it does have implications for habitability, for the habitability of this place, which I think is, as Alex talked about and his colleagues are working on, really vital for understanding the context in which migrations emerge. And I think this is just a beautiful example of how these partnerships between scientists and local community members can help to reveal the complexity of these relationships between environmental changes, habitability of places, and the potential for migration. So I'm going to end there with just to, I will underscore the point that where I hear us going is deepening our local knowledge through that can help us to inform our scientific models and understand better the complex processes that are behind all of these different kinds of migration that we're observing. So thank you, everybody, for your attention.
Hi, everyone. I'm Laura Lautz. I'm from the National Science Foundation, And thanks, Amir, for the invitation to participate in the synthesis part. I just want to acknowledge I wasn't a member of the planning committee or a speaker or a panelist or anything. And so I'm a bit coming from the outside and just capitalizing on this opportunity to share a little bit of information from NSF. So if you don't know me, I'm a geoscientist. I'm actually a groundwater hydrologist or a hydrogeologist. And so I'm in the Geosciences Directorate in the Division of Earth Sciences. Before coming to NSF, I've been at NSF for 4.5 years now. Before that, I was a professor in earth sciences at Syracuse University. So that's kind of the context I'm bringing to this workshop, which is a bit far from the scholarship around human migration that I've heard a lot about. So this has been a really great opportunity for me to learn. So although I'm a groundwater hydrologist and my expertise is really in earth sciences, and my primary program is hydrologic sciences, at NSF I work on several cross NSF programs that are really focused on the integration of social and environmental systems, or coupled natural and human systems. So some of you may be familiar with the Coupled Natural and Human Systems Program, or DICES program. I'm on that working group, and some others that are, again, cross NSF programs. And so I've been really paying attention to the presentations and conversation in the context of those programs more than like my own scholarship. So just kind of want to acknowledge that. So I feel we're short on time, and so and you all have done such a nice job of really synthesizing the content of the workshop. I think I'll just skip right to my part where I wanted to again capitalize on this opportunity to share information on a new program at NSF. So just last week, the Geosciences Directorate, where I am, announced a new program called CHIRP. That's an acronym because we love acronyms at NSF, and it stands for Confronting Hazards, Risk, and Impacts for a Resilient Planet. And so this comes out of the Geosciences Directorate, and it addresses NSF's priority right now, budget priority on build a resilient planet. This is a theme throughout NSF right now. And we are also at NSF increasingly focused on use-inspired research or transdisciplinary research focused on solutions and major societal grand challenges, how to translate the research that NSF does to solutions for people for some of the grand challenges that our country faces. So this program, CHIRP, it's led by the Geosciences Directorate, and it's in part informed by the Next Generation Earth System Science Report that motivated this workshop that is part of a series of workshops. So it's all sort of interconnected. And the goal of CHIRP is to advance earth system science as described in that report and talked about here, and also to draw connections between the geosciences and the social, behavioral, and economic sciences, the biological sciences, perhaps engineering, and also an increased focus on the new directorate, technology, innovations, and partnerships, which is again really about research translation. So that's a little just the context for the CHIRP program. And so what is CHIRP? And by the way, if you're Googling it, it's CHIRRP. So there's 2 R's in CHIRP. If you Google NSF CHIRP, it'll come right up. This is a new program, again, just announced last week, and the goal is to support community-driven research partnerships. So it's very community-focused and partnership-focused on earth system hazards, with the ultimate goal of developing actionable solutions for communities to help reduce risk and increase social and ecological resilience. So that's the overall goal of the program. And so we're looking for projects that show convergence of 3 essential elements. One is what we're calling equitable community partnerships. So this is really developing research questions and approaches in close collaboration with communities. So this community research partnership. Focus on an earth system science approach that can advance knowledge of hazards, impacts, and risks. And you all are familiar with this report. The earth system science approach articulated in that report really emphasizes the integration of the physical and social dimensions of the earth system, which we've talked a lot about today. And also a focus on actionable solutions. How can research actually help inform solutions for communities to reduce risk and increase resilience. This is the first year of CHIRP. It's very late in the fiscal year, and there's a variety of reasons for that, but the program has just come out. There's a bit of a short turnaround to prepare proposals, and this year we're really focused on capacity building. So many of the projects you all talked about, if you're interested in kind of spinning up components of those in preparation for maybe a larger proposal to a program with this focus in the future, this year would be a good year to look at CHIRP, because we are supporting planning grants, conference grants, research coordination networks, proposals called eagers, if you're familiar with that mechanism at NSF, or RAISE proposals. That's also an NSF term. I'm happy to talk to anyone who wants to learn more about those specifically, but first time I just am kind of mentioning what they are. And the goal is that these mechanisms could help you or any, the research community partnerships, help people develop those partnerships with communities if they don't already exist, provide training for more effective community engagement for these types of projects, catalyze ideas. So, communities and researchers working together to figure out what are the best questions, approaches, challenges that could be addressed through projects supported by CHIRP. And just overall help people with the initial conceptualization, planning, and collaboration activities that would put you in a good position to promote something in the future that's more larger and comprehensive. So if you're interested in learning more, we have a webinar this coming Monday, March 25th at 3 p.m. There's registration information online. You can always just shoot me an email and I can forward you the link to the registration. I really encourage you to come and watch the webinar. It'll be recorded if you're not available at that time, so you could check it out later. And also another selfish plug, in the Geosciences Directorate, in the division that's hosting CHIRP, we are actually looking for rotators and IPAs folks to work at NSF. And we're specifically looking for people with expertise in the human dimensions of climate change. And so if you're ever interested in opportunities at NSF, it's a really great time for folks with your domains of expertise to get involved and really contribute to the development of these programs. So thank you so much for letting me use this time to advertise those opportunities.
Okay, thanks all. I think we're at time. So we'll end on time, but I just wanted to thank you all so much. And logistically, I believe that there's a report that comes out of this workshop that's not a consensus study, but a report. And I understand that takes a little bit of time to put together, but imagine that, how would it be shared with attendees?
Share it broadly in our networks and also other friends.
Perfect. Okay. Thank you all so much.